Hello and welcome to another Zuzin session. How about that? How about that? But you didn't expect that shit to happen. So today we're gonna continue developing our text editor called Dead, because nobody's gonna use that, let's be honest. So that's precisely why it's called Dead. And essentially the idea of that text editor is that it needs to be as dramatic as possible. Let me demonstrate you what I mean by that. So if you start this editor like this, so this is how you greet it, right? So, and you start typing things, and this is basically what's happening. Right, so the rainbow shader is not like final thing, it's just like testing how shaders work. But yeah, so you have this like a very dramatic camera that follows your cursor and tries to center your cursor all the time, and that's your typing experience. And we're gonna try to improve on that and make it even more dramatic. We're gonna add more interesting different shaders and so on and so forth. You can even open the source code of the editor inside of the editor itself, and this is how it looks like. So you're sort of scrolling through this entire thing, and that looks pretty cool. So yeah, but here's the thing, it uses the bitmap font, very pixelated bitmap font, and that is kinda lame, not gonna lie. It is in fact kinda lame. So the thing I want to do today, I want to integrate a FreeType library with our editor. And the FreeType 2 Electric Boogaloo library basically allows you to render TTF fonts. I don't think it's a FreeType 2, I think FreeType 2 is located some... yeah, there we go. I keep forgetting where... yeah, so here it is. So it allows you to use TTF fonts. And I already researched a bit how to render TTF fonts with OpenGL. So, so OpenGL FreeType, is that what it is? I think it's located in my prop folder. OpenGL FreeType. Maybe it's a FreeType open. Yeah, there we go. I found it, and this is how it looks like. Yeah. So this is basically a technological demo, right? That uses TTF fonts, and the font that we're using is called Victor Mono. It's actually a pretty cool font that was recommended to me on the stream. I wish Emacs worked really well with this font, but it just doesn't. Emacs doesn't really work with that font well, so I'm gonna put it in the description for anyone who's interested. So Victor Monov. Okay, comrade. And also the source code. I'm gonna put the source code of the text editor in here for anyone who's interested, and of course in the description as well. Source code. So let me see. Alright. Alright, so let's go ahead and do that. Hello, Shigiman. Hello, hello. Okay, so let's go ahead and start working on integrating FreeType with our OpenGL renderer. So I actually found a pretty interesting article by Glyph Atlas. Alright, so it has a couple of interesting ideas on how to render FreeType with OpenGL, and I actually wanted to try this approach. The idea is essentially to take the glyphs that are generated by FreeType and sort of cache them into the texture atlas, right? So, and then use FreeType to determine the positions of the glyphs and stuff like that, put all of that into the vertex buffer, and then also give the shader the atlas glyph that you cached, and on a shader do all of the lookups and just render this entire thing as you supposed to render it. So interestingly, you do majority of the rendering on the GPU, but you still need a little bit of help on CPU to determine the layout of all of these things. So, and since the glyphs in FreeType, they are not the same size, they may vary actually, you probably won't be able to render it as a very simple cell renderer as it is right now. in our text editor. In our text editor, it's actually relatively simple. It's literally just a cell renderer, and every cell has the same size, which simplifies all the things. But if we add support for FreeType, it's not going to be true anymore, so our shader will become a little bit more complicated, right? Because it's not rendering cells like grid cells anymore. It's rendering rectangles with different textures. Right, and it's taking the textures from the texture atlas that we cached. Another cool trick that I learned from this article, by the way, I think I need to put this article in the chat and also in the description. So I'm not sure how good this article is, right? Because I'm not really familiar with OpenGL and stuff like that. But from what I read in this article, everything makes sense to me. I don't know if there's any like significant pitfalls with this approach, but I'm gonna just try it and see if it will fail over time or something like that. So here, the interesting cool thing that I learned from this article is that it doesn't make the atlas on CPU. What it does, it allocates the texture on GPU of a required size, and then it uses GL texture sub-image to actually fill in different things, different glyphs within the atlas. So I've already done texture atlases before, and I usually done them on CPU, right, directly just writing bytes and whatnot. And it never occurred to me that I can just like directly do that with the OpenGL calls, right? So I can just allocate the texture and just put the chunks using GL text sub-image. So, and I would presume that it would be faster, right? Because you're just also directly sending these things into the GPU. So, and I also want you to try that. I think it's a pretty cool idea. Never thought about it because yeah, I just always prepared it on CPU and just send it as one thing to GPU. So, yeah. So that's basically what I wanted to try. I think you showed how I see yours. Thank you. Are my eyes even visible? Yeah, I think my eyes have like a kind of similar color. Interesting. Thank you so much. I never noticed that. I'll keep that in mind next time. Because I personally like red t-shirts, but maybe it makes sense to wear something that people like more than I do. But it depends. Right. Would cases, refterm, text rendering stuff help at all with this? Probably. But I don't know anything about DirectX. So if you take a look at the cases refterm, and it's not only cases refterm, there were several people who worked on it, also Mosaico, right? So as far as I know, they were the initial implementer of this entire thing. For instance, they're using HLSL, which I'm not familiar with. Like, I don't understand this thing. I only know GLSL. Though I do roughly understand what's going on in here. Roughly, but not too much. Right. So for anyone who's interested, so we're talking about this thing. Okay, so... Refterm. So since this entire video is going to be on YouTube, I also maintain the things that I'm going to put into the description, right? So people who watch this offline can check out all of the links that we're talking about, essentially. So that's what I'm trying to do here. Okay, go. So let's see how we can integrate FreeType with our text editor. So right now we have a special VAO as far as I can tell. Right, so basically this is a single vertex that we send to our GPU. Right, so currently it consists of the tile, right, in which tile you render a character, the character itself, right, and the foreground color and background color. So, but these kind of glyphs are not compatible with FreeType renderer, again, because it's not a tile renderer anymore. Right, so I think this could be something like, I know, maybe we're gonna call it something like FreeType glyph. FreeType glyph. Right, and instead of the tile, I suppose it's gonna consist of It's gonna consist of position, right? So it's gonna be something like that, and the size. In case of our original glyph renderer, all of that stuff is determined by tile and global scale uniform, right? So in case of a tile rendering, we just have a global scale uniform that scales all of the glyphs at once. So that's why you can just only specify the tile. In case of a FreeType, I think we'll have to specify both position and the size. All right, so then we'll have to specify the code, right? The code of the character that we're trying to render, and that code is going to be used by the fragment shader to look up the corresponding subtexture in Atlas. And of course, we may also have something like background color and foreground color, right? So in that particular case, they're not that different. Nuligor, thank you so much for 11 months of tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic FreeType club. That's right. Free the types. Free the types. Stop making types dependent. That's the joke only Haskell developers will understand. That's the joke only Haskell developers will understand. All good, Zozin? Of course not. Everything's bad. I'm going insane. So yeah, but thank you so much for almost a year of tier 1 subscription. I really appreciate it. Free the types. Yeah, so in functional programming community, there is a concept of dependent types. Dependent types, right? I have huge problem with anxiety and constant panic attacks. Of course, everything is fucking bad, but it is what it is, and it isn't what it isn't. So yeah, dependent types, and we also have a library called FreeType, so that's basically the joke I made. So free the types, stop making them dependent. So this is going to be the VAO, but basically the vertex that we're going to send to the shader, and shader will render everything accordingly. So maybe I want to actually rename some of these glyphs to something else. Not really sure how I'm gonna call it. So the original glyph is based on you know, this old school texture, right? So so something like old school texture, right, which has a very specific format like this. So it's basically an atlas, pre-computed atlas for you. Tile glyph, maybe sounds pretty good idea, I suppose. Tile glyph. All right. So a tile glyph, and this one not necessarily has to be a FreeType glyph. It could be a free glyph, right? So it's located like freely. This one is locked into a tile, and this one is a free glyph, right? So yeah, that makes sense. That makes sense to me. So tile glyph, then we have basically enumeration that enumerates each individual field in the structure, right? And we use those enumerations as the vertex IDs, right? So, and we refer to these vertex IDs through the shader, right? So you can find them in a shader somewhere in here. Yeah, here they are. Here they are. So it's actually pretty cool how all of that corresponds to the structure. It's pretty self-explanatory. So there's also definition that gives this kind of offsets and whatnot. But not really sure if this kind of like structure is actually useful. So it is useful in a sense that this assertion will trigger, and then I can go and add a new thing, and down there somewhere we have a loop that iterates through this entire thing. But what if we get rid of that table and unroll that loop and put this static assert in that loop instead? So I think technically, like, it's going to be the same thing, right? So you unroll the loop, you still have the table of all of the vertex definitions and plus assert. So I guess this kind of thing it's useless. I truly think it is redundant. So maybe the first kind of refactoring that I'm gonna do right now is basically getting rid of this entire thing. So yeah, let me see. So I'm gonna try to recompile. Maybe I need to fetch the latest changes, by the way. Oh yeah. So let's for now rename it back so there's no compilation errors. Right. So let me double check. I really don't remember if I fetched everything. Oh, OpenGL renderer. Yeah, I do need to fetch some things, that's for sure. So I have some changes in here and I'm gonna stash them. Yeah, so I have some branch that I merged already. Merge origin master, and let's remove this entire thing. So we're gonna have FreeType. So we created a separate branch called FreeType. And let's do build.sh. So I didn't think this thing is particularly useful. That's what I wanted to say, chat. I didn't think it's useful. Sorry. This thing has to go. Same as me. Depends on how you evaluate usefulness, right? I don't have a T. So in the way I evaluate usefulness of this code, it's useless, but depends on how you frame it, right? So there we go. So you're useful for your employer. That's pretty cool. Otherwise, they wouldn't pay you, right? So makes sense to me. All right. Glyph attribute. So here are the definitions, and this is probably where I'll have to sort of unroll this entire thing. Okay, so let's actually go through the compilation errors. We're gonna do a compiler-assisted refactoring. That's what we're gonna do. So again, this entire thing has to go, right? And I'm gonna put glyph. So let's put this thing somewhere here. Another one. So in here, we're switching between those things. Okay, so essentially what I want you to do, I want you to turn each individual definition into a single GL vertex at 3 pointer call. Right, so that's basically what I want you to do. Right, so if we take a look at this thing, I can simply copy paste it in here. So this type is integer. So I'm enabling attribute tile, right? So this is the attribute tile. So the type of this thing is an integer, right? It is an integer, so that means the second call has to be called that. The amount of components in here is 2, so maybe this one has to be something like comps. The type has to be an integer, a GL int, so type. Size of the glyphs, and offset is effectively the offset of this entire thing. So this is the tile. All right. You know what? I just realized so that it's really easy to make a mistake in here, maybe. It's relatively easy to make a mistake because you have to repeat this thing 2 times, and if you copy paste this thing several times, it might be a huge problem. So this kind of approach does solve some of these things. I didn't think about that. Yeah. So it makes it difficult to introduce a mistake through a copy-paste, because I do remember that I actually had mistakes with initializing the vertices by copy-pasting stuff around. So maybe that was not a good idea to get rid of that, so let's not do that. Interesting. It's interesting how you think it would be a good idea until you like start doing that and hit some sort of like a roadblock that tells you, nah, it's not actually a good idea. Very interesting. Hello Valony, welcome to the stream. Does it ever occur to you when people think you're programming God and get shocked when you go— What are you talking about? I have no idea what you're talking about. There's like a huge amount of people who thinks otherwise. All right. Okay, so what we're gonna do instead? We're gonna try to we're gonna try to actually rename this entire thing. I want to call this a tile glyph. Right, so this entire thing is gonna be a tile glyph. Tile glyph attributes. This is a tile glyph. So you know what? I think this has nothing to do with tiles glyphs per se. I think it has nothing to do with glyph per se. It's more of a like attribute definition. So maybe because of that, it's gonna be just called attribute definition, and you're gonna have several attribute definitions depending on VIO that you have. So yeah, that makes sense, I think. So this is the glyph. It's a tile glyph buffer cap. This one is a tile. This one is a tile. This one is a tile glyph buffer. So I'm making all of these changes so the compiler will, you know, will complain when we try to compile this entire thing, right? So, and once we rename all of that, I'm gonna actually pull off the tile renderer into a separate unit, and we're gonna sort of like archive it for usage later, right? Because I want to be able to switch between different kinds of renderer, like between the tile renderer and the free renderer, FreeType renderer. Okay, let's go through this entire stuff. So, this one is going to be simply, I suppose, attribute definition, right? So there's only one of them in here. Next one, count glyph. Let's replace this stuff with tile glyph. All right. Okay, so maybe I can just go through this entire stuff. What is this song? It's a little bit creepy, not gonna lie. Okay. So if I try to replace this entire stuff like this, it's gonna be tile, great. So might as well replace this thing with that stuff. Alright. Hello Monica Life, welcome to the stream. How are you? So let's go replace this stuff, tile glyph buffer cap. Alright. This one is interesting. Should have actually Okay, looks good to me. So this is a glyph, it's a tile glyph attribute. So this is another tile glyph. Okay, so we managed to refactor everything. So in here, yeah, this entire thing is just renaming of glyph to tile glyph. Rename glyph to tile glyph. Right, there we go. We did that. Let's push that right into the repo. So, and what I'm thinking is that we need to extract everything related to tile glyph rendering to a separate unit. I think that's quite important. So tile glyph. Yeah, let's just call it tile glyph, I think. If not defined, tile glyph h define and if okay. So this one is going to be a tile glyph. We're moving it in here. This one is basically the attribute for the tile glyph, right? So this is the attribute. So this is the attribute definition. But I don't think the attribute definition could be shared between different renderers, by the way, between different VIOs. So I'm not really sure where we're going to put all of that. But for now, I think we're going to put it maybe somewhere here, right? So why not? Why not put it somewhere here? So for this one, I want this to be like an array. Some sort of an array. To be fair, this thing might be actually private to the entire translation unit itself. So tile glyph.c, and we're gonna include tile glyph.h, right, tile glyph.h, and that's where we're gonna keep all of that. So where is this stuff? So it's going to be something like this. So we moved it here. So now we need to copy the buffer. So this is basically where we keep all of the glyphs that we try to render. So we first populate this entire buffer, and then we send it to GPU, and then GPU renders this entire thing. So yet again, I think this kind of thing can be completely private, right? So there's no need for the user to even see this thing, because the user interacts with this memory through buffer clear, buffer push, buffer sync, and so on and so forth, right? So there's no need for the user of this translation unit to know that these kind of things exist. So I think that's totally fine. But one thing we need to do in here, we'll have to expose these interfaces, right? So you have a glyph clear, then you push the glyph like so. Alright, so then you synchronize the glyph like so. So, and we're relying on global variables because I don't expect to have like two separate VAOs for tile glyph render, at least right now, but maybe in the future we're gonna have them. We'll see, we'll see. Render text size. So this one could be actually also part of the interface. Yeah, I think so. When you say translation unit, you're referring to module.c.h, kinda, but translation unit is actually way more than that. Translation unit is everything that goes into a single O file. And the thing that goes into a single O file can be actually a lot, because you also include a bunch of shit in here. So it's not only just .c and .h, it's also everything that they include. So because the C file includes everything, right, and then that single thing is translated into a unit. And then you have a bunch of units, and all of these translation units then linked into a single executable. So, and furthermore, translation unit is a C++ term. It's a well-established C++ term, and you can Google up this kind of thing. So essentially, if you Google C, translation unit. So it's a like terminology, it's an official terminology. So yeah, in C++ programming terminology, translation unit is the ultimate input to C and C++ compiler from which an object file is generated. So when I say that, I refer to like very specific definition. And of course, I think I can actually put that in the description and in the chat as well. Right. Okay, so the description. Translation unit. Okay. All right, so tile glyph.c. Okay, so where is the declaration and where's the definition? Okay, so we need to take the implementations now. All right, so this is going to be clear, this is going to be push, this is going to be sync, and I'm going to put okay. Okay. So I kind of want to rename this thing because this function can only work with tile glyphs, right? So it has to be something like tile glyph render text size. Yes, I think this is how it has to be called. Right, it accepts the text, then the size of the text, then the tile where it's going to be located, the foreground and background color, and just like renders the line. Maybe... Yeah, I think it should be called render line because it doesn't do any new lines, right? So it's a single line, tile glyph render line sized. And because of that, I think this thing should be called something like tile glyph render line, but not sized, right? So because it's not terminated, but it's implemented in terms of the sized function anyway. Right. So, and this function, even though it renders the cursor, it still does that through the tile glyph renderer. So we can do something like tile glyph render cursor, right? And editor character under the cursor. This one is interesting actually. So it's really well integrated with the. Okay, looks like it's not really related to a tile renderer. Right, because it's basically glued into the tile glyph. So that means we're gonna just simply call to this function, right? So that's what we're gonna have in here, and yep. Let's move this entire thing to the tile glyph header. So this is gonna be that. And this is the second thing in here, right? So, and let's grab those implementations, tile glyph.c, and let's put them in here, right? So, okay, looks good, looks good. So, and I also want to move some things related to VAO initialization to separate functions as well, like this kind of stuff, right? So, should be something like tile glyph buffer init. Yeah, I think it has to be something like init. Yeah, makes sense to me. So tile glyph.h, so clear, push, sync, then render the text, and we can have something like tile glyph buffer init, right? So just simply initialize that, and this is gonna go there. Hello Andrew, I hope I'm pronouncing them correctly. You're skilled. How do you know that? I'm actually literally pretending doing something and just typing random characters on the screen. Tricking people into thinking that I'm skilled. So... you have no way to verify that I'm actually skilled. Maybe it's just like I'm literally typing random shit. How do you know? How are you able to code without inline syntax error? I can't trust myself that much. So having trust actually has nothing to do with being able to code with or without inline syntax errors. So if you don't trust yourself, you need some sort of way to check that you didn't make any mistake, right? And inline syntax error is only one way to check that you didn't make any errors. The other way would be to have a separate command that goes through your entire code and checks it and gives you the summary of the mistakes that you've done. So It has nothing to do, your trust into yourself has nothing to do with very specific implementation of syntax error reporting. You see? So it's like a completely orthogonal axis. So on one axis is your trust in yourself, and the second axis is the way the syntax error are reported. So it's just like I use a different way of reporting syntax errors. I usually look at my syntax errors after I've done outlining the idea. So you see what I'm talking about? Like it's irrelevant. It's two separate things. They have nothing to do with each other. You see what I'm talking about? So that's how I do that. It's just like I get the syntax errors from a different way, right? They're just not in line. They're postponed, right? So I use a retained syntax error approach. You use the immediate syntax error approach, right? You type and it immediately tells you, but I use a retained one. So I first outline the idea without any tool interrupting my trail of thoughts, and then when I'm ready, I tell the tool, tell me where I made the mistakes, and then I go through the mistakes and then I fix them. So I'm not like, you know, yeah, I'm still using some sort of reporting, it's just like a different time. Okay, this makes sense. I'm really glad to hear that. All right, so anyways, okay, so here's the texture. We also need to initialize the texture for this entire stuff. Chat is extremely annoying today. So yeah, buffer initialization. So we prepared the buffer, but that's not enough actually. All right, because we need to also load the texture, right? We also need to load the texture. So maybe we're gonna put that into yeah, tile glyph load texture atlas. Texture atlas, and this is going to be something like const char file path, const char file path, and all right, so this is going to be that font file path. This is going to be file path. Okay, so we're going to be using STBI in here. All right. So, and we're also initializing the shader. But I'm thinking, should it be part of the glyph thingy? Because for the free glyphs, we're going to be using completely different shaders, right? And though I also want to specifically rename my shader files to be something like tile glyph, tile glyph. There we go. Tile glyph. Okay, so. Did I already copy-paste it? Tileglyph.c. Yeah, I already copy-pasted everything. So initializing this thing is not needed. We already initialized the buffer. Initialize shaders. Sure, I can also do this kind of stuff. So tileglyph.h. Right. So you initialize the buffer. Right, then you load the texture atlas, right, you load the texture atlas, and you also compile the shaders, right? Compile shaders, and here we can provide something like vert file path, right, and then frag file path. All right. So, and I'm not even sure. Tile glyph, low texture atlas, compile shaders. So, where are we going to be pushing that? So this is going to be somewhere here, and this is where we're going to be initializing the shaders. Right. So this is where precisely we're doing all that. So this one is going to be the vertex shader, right? So the vert file path. So frag file path. Frag file path. Okay, so and essentially here we also have different uniforms. All right, different uniforms. So we have essentially time uniform, resolution uniform, scale uniform, and camera uniform. And I'm thinking, does it make sense to actually put all of that stuff into some sort of a structure, right? Because as a user of that tile renderer, you want to be able to access these kind of things, right? So maybe, right, you want to actually be able to do to have an access to all these things, if you know what I'm talking about. So maybe we could put, like, initially I said that I didn't want to put all of that into a separate structure, but maybe I should. Right, maybe I should put that into a separate structure along with the uniforms. So then whoever uses this entire thing, they can just, you know, just try to use that. But that also means that I have to pass this kind of stuff everywhere. But maybe it's going to be worth it. I think it's going to be worth it at the end of the day. Alright, so let's define the renderer. So this is going to be type def struct. Okay, tile glyph. This is going to be called buffer. Not sure if I want to call it buffer. But I mean, I already call it a buffer like everywhere in here, so maybe that makes sense. Right, tile glyph.c, and so because of that, I'm going to put this entire thing in here, and this entire stuff will become just that, part of this entire thing. Okay, so this is the count, and this is the capacity and stuff like that. And as already mentioned, right, so as already mentioned, I want to have the uniforms inside in here, right? So here are the uniforms. But on top of the uniforms, we could also put a lot of things in there, like texture ID, right? Texture ID, the ID of the vertex buffer, the ID of the vertex array objects. All of these things can be actually put inside of this structure, so the user has the access to them, right? So we're actually pulling it into like its own rendering thingy, and we're sort of establishing the standard on how this kind of render is going to be implemented, right? Once we have this solid tile renderer, tile glyph renderer, we're gonna implement the FreeType renderer in a similar fashion, right? So we're gonna have a FreeType glyph, which has a slightly different structure, right? It's going to have its own attribute enumeration, then it's gonna have its own structure with its own uniforms and stuff like that, and also a bunch of functions that render things in a similar manner. So yeah, we're sort of like designing how this renderers will look like from the user perspective, if you know what I'm talking about. Right. Okay, so and when we are initializing this entire thing, I think we're going to be actually getting the pointer to the buffer in here, and we're going to actually smash all of these things together. So you'll have to provide the texture file path, right? So you provide the buffer into which you initialize everything, the path to the texture, and the path to all of the shaders, right? So, and yeah, I think it's going to replace all of these functions in here, right? So you just have to take the structure, allocate it somewhere in a memory, in a dynamic memory, in a static memory, maybe on the stack, if you have that huge of a stack, right? And then you just initialize it and prepare everything, and so on and so forth. So, and then you have a tile glyph buffer, which is like the pointer in here, right? So then you put it in here, right? So we'll have to actually pass it everywhere. Okay, so this is going to be something like that. So let me, I already lost it from my buffer. Already lost it from my buffer. There we go. So, but that will require going through a lot of things in here. Okay, so after we initialized everything, the only thing I need to do in here is just like allocate the tile glyph buffer, right? So this is going to be TGB, I don't know. We can call it TGB, why not? So then I give the TGB pointer. So the path to the texture is located somewhere in here. It's literally located in here, so I can just do it like that. Right. So the shader, the vertex shader, is located in shaders, right, in shaders like this. Right, and then shader style glyph frag. There we go. So this is how we're going to be initializing all of this stuff. All right, so I think I've done enough of the, shaping the code, right, and we're ready to do the syntax and semantic analysis, also known as compilations, since 1970. Right, so since 1970 we have a very specific term for analyzing syntax and also semantics and also type checking. That word is compilation. So, and that's precisely what we're going to do right now. We wrote the code and we're about to do the compilation. All right, so let's quickly do that. So I think I'm gonna go in here and there we go. There we go, here are the errors. Somebody asked in the chat, how can you work without like syntax error, reports? Here is my syntax error report, right? I wrote some code and I don't want to get interrupted by the compiler or the analyzer all the time, so I postpone that step for later, right? So I outline the idea, high-level idea, and then I ask the compiler, give me the report of all of the errors. And this is actually a pretty good report because I can click on these things and precisely go to the place where it happened. So it's pretty cool. That's how I do that. So that's how I prefer working, because I find it personally annoying with the text editor like constantly interrupts me with it's wrong. I know that it's wrong. No need to tell me. I'm in the middle of shaping the code to a particular shape that I want, and of course it is wrong. From the point when the code has no feature and code has feature, in between the code is gonna be incorrect. I already know that. So no feature, feature implemented, in between code is incorrect. No need to tell me information that I already know. I know that it's incorrect because the feature is freaking unfinished. Okay, once I finish the feature, I don't know if it's fully correct. Only then I check for the errors. Make sense? Makes sense? Makes sense to me. It's a pretty straightforward approach. Nothing particularly special. People have been developing like that, as I already said, from the 70s. There's nothing new in here. All right, so what do we have in here? Have I seen you mean Copilot? I've seen it, of course. I actually seen it. All right, let me see. Tile glyph. Okay, so the tile glyph.h. So that's basically what I want you to do in here. And I'm going to also add this thing in here. So it's going to be src tile glyph.c file glyph.c. They finally did it. Deprecated programmers. Luckily, I'm not a programmer, so I'm not losing any job. Alright, so tile glyph, tile glyph buffer, so it's gonna be TGB, so this is the pointer, and in here I suppose we'll have to pass the TGB. There we go. Okay, so resolution uniform, it's gonna be TGB resolution uniform. Alright, next one. Might as well actually, so this is gonna be TGB, geo-render text sized. Okay. Tile glyph, glyph render, render line sized. Right, so this is gonna be TGB. Okay. So TGB. Anything else? TGB. TGB stands for tile glyph buffer, right? So, all right. And TGB tile glyph count. All right, looks good to me. Anything else? Yeah, so what I'm doing right now, by the way, it's called, I personally call it, it's not really a thing, but I personally calling it a compiler-assisted refactoring, right? So essentially, I make some changes in the signatures and the definitions, and then I just run the compiler and go through the compilation errors over and over again, fixing them. So I'm using the compiler as the ways of guiding me through the process of refactoring things. Right, so yeah, because obviously if you change the definitions of the core things in your code, like structure definitions, any sort of type definitions, or signature functions definitions, and so on and so forth, the places that use those structures, that use those functions, they will automatically break, right? And if you go to that places and fix them, effectively you perform the refactoring. And actually you performed a very precise, very self-aware refactoring that you won't get with any sort of IDE. Right, with IDE you can refactor very, very fast, but only narrow class of refactorings. With compiler-assisted refactoring, by changing the definitions and then following compilation errors, you can perform way more precise and way more sophisticated refactoring than with any IDE, in fact. So car, yeah, I mean the abbreviation of compiler-assisted refactoring is car. So yeah, so people quite often ask me why I'm using such a rudimentary environment, right, without any IDEs, because the compiler is my IDE. It tells me where I made mistakes, and it also guides me through the process of changing my code. Like it performs all of the necessary tasks of the IDE for me. So yeah, so I don't know what to say. It's just like, yeah. I just don't need this kind of things. Like the compiler does all of that for me. So there's a couple of things that I would like to have in statically typed compiled languages, but apart from that, yeah. One of the things I want to be able to do is essentially have compile time messages, right? You can already have something like error or warning, but I want to be able to say something like, okay, I have a variable, right? Something like TGB. I want to find where it was defined, right? I want to find where it was defined, and then I want to print that at compile time. Right, and what I want the compiler to do while it's compiling everything, it will issue a diagnostic message with precise place where this variable is defined, so I can go to the definition of that variable in my editor, in my text editor. And since the compiler knows all of the variables, it can precisely tell you where things are located, even in the third-party libraries. I wanted something like that in C and C++ compilers. Unfortunately, it is not a thing. I'm working on my own language, so maybe I'm gonna actually add this kind of stuff there. right? So I want the language to be self-explorable, right? The compiler knows precisely where things are located. Why can't you just tell me that, right, from time to time? Can you do that from GDB? GDB is a debugger, and it relies heavily on debug symbols, and debug symbols don't contain all of the information that the compiler has. Alright, so the compiler has everything, and I want to have an access to that everything. Alright, so it's gonna be something like that. Oh, and of course, this kind of thing is gonna actually work really well with CM, of course. Okay, so we have a size t offset, so maybe I'm actually gonna do something like alright, so GLU int, and I suppose to have all of that we need to maybe include so SDL2 SDL OpenGL.h, right, OpenGL.h. So it is okay. Oh, I know what is going on here. Yeah. So if you don't include the assert, it will never tell you that you didn't include assert. Instead, it will tell you that I cannot parse that until you include assert. Thank you, C compiler. Very cool. Super cool. Not gonna lie. All right. So, and we have to go through this entire thing and also do tile glyph buffer tgb. Right, and let's just go through all of these things. So here's another one. So I want to make a cup of tea actually, kind of craving for a little bit of that tea. Tile glyph buffer tgb. Alright, and okay, what's gonna be the next compilation error? We have a bunch of them. Oh yeah, so now every time I access any of these variables, I'll have to like prefix them with tgb, of course. So I wonder in how many places we'll have to do that. So maybe I'm gonna actually employ you know, renaming like that. So tgb, boom, boom, boom. Okay, so it's gonna speed up some of the things a little bit. So this one is gonna be something like tgb this one is not needed. This one is very unfortunate. Okay, so we have to be super careful. So this is the initialization. This one is quite important. Okay, so this one is done. Anything else? GL buffer subdata. Okay, so this is something that is located in sort of like extended OpenGL, and I suppose we'll have to enable this thing in here for the prototypes. I do remember having that problem before, so I think this is how we fix it. Okay, so this one requires additional stuff in here. We're almost done, by the way. Too few arguments. Are you sure about that, buddy? Let me try to recompile. So you see, right now I'm sort of in a phase of, like, I'm not even developing anything, right? I'm in a phase of just going through the compilation errors and just like methodologically fixing them, right? So right, I don't even need to think about that. It's just like a no-brainer, just refactoring. Very methodologically, passing one argument, so this is going to be tgb, strlen. Okay. STBI load. Okay, so that means here we'll have to include stb image.h, right? So because we're loading images and whatnot. Okay, so unused variable. Okay, so here we have not matching signature of this function, so we'll have to fix that. So TGB, why does it say that it's unused? That's really strange. Not quite sure, even though... Ah, it's called buffer. Alright, so that explains it. That explains it. I think I know. I wanted to move font texture into the TGB. Right, that's what I wanted to do. Just move it into the TGB. Tail.h, tile, not tail. So here we have all of the uniforms, then we have a font texture. Right, and every time we're doing TGB font texture, I might as well actually go through this entire thing. So query replace font texture, TGB font texture, right, something like this, and there we go. So do we need anything else? I don't think so, actually. So the pixels, do we want to store these pixels? Because as we sort of like loaded everything successfully, we don't really need those pixels anymore. We might as well actually free them. So as far as I know, STB allows you to do something like STBI free. Yeah. But on top of that, it has like so STBI load. Right, image free, there we go. So that's what you're doing here, right? That's how we free the pixels. There we go. So because after we put it into texture, it's like really not needed. So there's no need to leak the memory or, you know, any stuff like that. Just remove that thing. Okay, so this one requires std bool. Another problem. Texture file path, unused variable. Okay, so that makes sense. Okay, so I think we need to start like moving things into a single function. So I want to move VAO inside of the things, right? So here is the place where we're gonna put that. So we have VAO and VBO, right? So I want to move everything in there. Replace VAO TGB VAO. There we go. So and VBO TGB VBO. There we go. All right, I think that's pretty much it. Okay. So this one, initialize vertex attributes. Right, so we initialize the vertex attribute. Here we are initializing shaders, if I understand correctly. Right, so init shaders. There we go. And we also need to move the everything related to the texture. Init texture. There we go. So we initialize the texture. Okay, cool. Vertex attributes, shaders, texture, and that's how much time it takes to initialize this entire render, right? So you need to initialize all of these things in here. Let's see how it goes. So compile shaders. So this will require additional module in here. GL, I think extra, something like that. GL extra. All right. Anything else? All right. This is something unfamiliar. It has something with glue, I suppose. Maybe that's what we need to include in here. I'm afraid that we're gonna start actually having problems because I don't recognize this problem and I hate it. Alright, so is it gonna work now, please? Please work, because I don't want to do... Okay, so apparently it was fine. Yes, TGB, something like that. Do we have anything else? Any other problems? Scale uniform, TGB. I think we're almost done. Font scale. Okay, so where is the font scale is defined? Font scale is defined. Okay, so that has to be part of the tile glyph.h. So it's going to be located somewhere here. Okay. So this is the file path, and this is the texture file path, right? And okay, so texture file path. Cool. There we go. I made a pretty huge refactoring without any IDE. So this is how much I removed. I also pulled off to a separate thing, like a lot of stuff, right? I extracted like the 169 lines of code, and all of that compiles, doesn't have any type errors, and if I try to run this entire thing, it's seg false. Right, so let's try to find out what exactly is going on in here and where exactly it's seg false. I wonder if I try to run this. Okay, so it's seg false pretty reliably, I would say. So let's run this entire thing and let's see where precisely it's seg false. It doesn't even tell me the place where it's seg false. It's 72. Okay, so it's 72. Access memory at address. I'm actually confused. So what if I try to like not initialize the... Oh, I know what is going on. So I'm allocating this thing on a stack and it actually like ripped, like tear apart the entire stack. Alright, so if I try to, if I try to recompile this entire thing, let's try to do that. So yeah, the object is just too big. Hello Gia, what's up? And it seems to be working. There we go. So I just needed to allocate the object on the static memory rather than the stack memory, right? Otherwise you're gonna tear the stack apart. So yesu. Let me put it in here just in case. Right, so yesu. And there we go. We have like you know, tile glyph renderer. So, and I also want to do a couple of things in here. So I want to get rid of this, how do I say, of these prefixes, because they don't contribute anything, right? They don't contribute anything because we already have a prefix of the structure. So we can do something. We can call this glyphs, right? So here's the glyphs. And this is going to be the glyphs count, right? So this is the glyphs count. Okay, so we're gonna replace this entire thing with glyphs count. Okay, so this is going to be the another one. Should have actually done something like this. Glyphs count. Query replace glyphs. Oh, and this one is going to be super annoying. Okay, so I need to do it like this. Yeah, this one is glyphs. Hopefully that will do the trick. And I think it did. I think in fact it did. Alright, so this is the tile glyph renderer. Pretty cool. So I also wanted to move some of the things that, oh my god, Emacs, that basically perform the draw calls, if you know what I'm talking about. So here, yeah, I think I wanted to extract that. Just draw. So when do we try to access these things directly? So we try to access directly uniforms. Yeah, I think we need to move the draw call to a separate function. So it's going to be tile glyph, tile glyph buffer draw. Right, and we accept tile glyph buffer. It should be called TGB actually. Oh well, it's already called buffer in header. Okay. So, and in here, we're gonna perform this draw call. There we go. And in all of these places, instead of this thing, we're gonna be just doing TGB. So it's gonna be pointed to TGB. So we draw, and then one more time TGB. So yeah, here we essentially prepare everything. Then we we render this entire thing, then we draw it, then we clean, render the cursor, synchronize, and draw yet again. Yep, I think we successfully pulled off the tile glyph render thingy. And it took us roughly an hour. To extract this entire thing without any IDE, but who knows, maybe with an IDE it would be way faster. And I'm wasting my time, being so unproductive. Oh my god. Wasting the company's money. My god. Alrighty, so let's go ahead and do a committee, and maybe then even pushy. Factor out the tile glyph renderer. I would rather prefer to call it tile glyph renderer, but I can rename this kind of stuff a little bit later. It doesn't really matter that much. Investors are unhappy. Majority of my investors don't even know what the fuck I'm doing. So, you know what? I think we should make a small break. I should make a cup of tea. And after a cup of tea, after I make a cup of tea, we'll go and basically create the FreeType renderer, right? So, yeah. Let's continue. Thank you. Welcome back to you too. So we factored out the tile glyph renderer. Now we need to do the same for the free glyph renderer. And as in the beginning of the stream, we established that the free glyph renderer looks something like this. Right, I'm gonna actually copy paste the definition of this thing in here, and maybe we're gonna even create something like a free. So we have a tile glyph, and we're gonna have a free glyph. .h. So this is where we're gonna keep the definition of the free glyph. Right. If not, yeah, free the glyph. Yeah. If not defined, free glyph h, and then we're gonna define this entire thing like so. And can I just move it down there? There we go. So in a similar fashion as with the tile glyph, we're going to have an enumeration, right? So free glyph attribute. So here we're gonna have more attributes. So in the case of a tile glyph, I think we have like 4 of them. Here we're gonna have 5 because we have additional size. So type def enumeration, free glyph attribute, right? So, and we have free glyph attribute position, so where it starts. So this is going to be a 0. Then we have a size. Then we have the character. So it's rather more of a like a glyph index. Right, but maybe in the future we're gonna rename that. I don't think I'm gonna focus on it too much right now. So I'm just gonna call it ch, but I think more correct would be call it like a glyph index. Right, so this is gonna be free, and here we're gonna have a count of all of these things. Okay, so the attribute definition, interestingly enough, that it doesn't need to be visible outside of the tile glyph. We might put it somewhere here, right? So, and I guess that's pretty much it. So we have a glyph, we have the enumeration that describes all of that, and we just need to define a structure that holds the state of the free glyph renderer, right? So it's going to be free glyph buffer, right? So it's a free glyph buffer. So, and we're gonna have also a lot of things in here, like different uniforms for time, resolution, maybe for scale. I'm not sure if scale is gonna matter, but also definitely for the camera, right? But we're gonna start with just a list of glyphs, right? So we're gonna define free glyph buffer capacity, and it's gonna be 640 multiplied by 1000. There we go. So, and we're gonna have a glyphs count, how many glyphs we already have in the buffer, and the array of the free glyphs. And we're gonna have 640,000 of them. Isn't that amazing? I think it's goddamn amazing. I suppose we're gonna be initializing this entire thing, right? So for now, we don't really need the texture file path. I don't think so. We'll probably need to pass like a ft face, right? An ft face is a type from the FreeType library, ft face, but that means we'll have to initialize this the FreeType library. Andrew LA, thank you so much for tier 1 subscription, your first subscription by the way, and welcome to our epic shader club. That's right, that's what we're doing here. We're doing shading. Cheers, by the way. LA, yeah, LA indeed. Alrighty. Shade me senpai. Been watching your streams for a while. Your versatility is truly inspiring. Learning a lot from you. Keep up good work. Thank you so much. I guess a lot of things that I do, they're just not needed anywhere. So that's precisely why I'm doing them on the stream. All right, so let's do this kind of thing. So this is going to be the clear, and yeah, I think I forgot to, like, I copy pasted things, and I'll have to query replace style with free, and we're going to have a couple of these functions as well. So like this. So do we need to have like a line? I'm gonna implement that line a little bit later. For now, so this is gonna be like the minimum interface for the text renderer, right? So you need to be able to first of all initialize your text renderer, then clear, push a glyph, synchronize the buffer with like GPU, and then draw that buffer, right? So that's like a minimum interface for the renderer. Additional thing here like involves rendering a single line, but all of that is implemented in terms of these functions anyway. So we're slowly designing sort of like the API for these kind of things. Maybe because of that I could have just like copy-paste these functions in here, like so, and just remove that, and replace style to free, and there we go. So here is the interface. We can then take this entire thing and create free glyph.c, like so, and just stop all of these functions. We're gonna include free glyph, glyph.h. So this buffer is not implemented. I'm not going to include face right now because we first will need to initialize the FreeType library, right? So this is going to be a completely separate topic, right? So here we're going to have assert 0, indicating that this thing is not implemented yet. Assert.h. Clear, I can implement it right away, I'm pretty sure. Let's actually rename buffer to TGB. It was TGB, now it should be called FGB, right? So it's essentially a free glyph buffer, and I can do the same thing in here. Boom, FGB. So there's another, I can see another buffer in here, so here it is, it's going to be FGB. There we go. Okay, so this one is gonna be void VGB assert 0. Void VGB glyph. So 0. Might as well copy paste these things in here. And then copy paste these things in here. There we go. We stopped the translation unit. We'll need to add the new translation unit to here. Freeglyph.c. Okay, so does it compile? Let's find out. Alright, so yeah, it doesn't know anything about linear algebra stuff, so let's include linear algebra unit. So here we have a glyphs count, so, and it doesn't know about size t, so we'll need to include stblib for the size t. So, and face, we don't have a face yet. Alrighty. Okay, so that's rather interesting. So we also probably need to have shaders for the free glyphs, right? So we only have tile glyph shaders like vertex and fragment. So let's actually quickly stub the shaders for the free glyph, right? So it's gonna be free glyph .vert, and I might as well actually use the tile vertex shader as a reference. So this is going to be version 330 core. So in terms of the layout, we're going to have freeglyph.h, right? So this is going to be layout location 0. In the location 0 we have vector 2 position. In the location 1, so I'm just like following the structure in here, you're gonna have the size. Then in location 2 we're gonna have an integer for the character. Location 3 is gonna be vec4 for the foreground color, right, and then 4 for the background color. To be fair, I'm not sure if we'll need like foreground, background color stuff, but so maybe foreground color is gonna be enough, but we'll see how it goes. Okay, so tile vert, so we're gonna have that, and in here, I guess we'll have to generate UV coordinates first. So, and we're gonna pass the UV coordinates to the fragment shader as well, right? So it's gonna be pretty much the same thing. So, and in here, we're gonna just make the position completely based on the UV coordinates. So this is just a step. This is not like a final shader that we're gonna use for the free glyph renderer. It's just like it generates the quad, nothing special in here. We can even try to center that quad like so. So it's a 1x1 quad centered at the center of the screen. So nothing particularly special. Once we have the entire pipeline working, we can start like doing some other things in here, I suppose. Okay. For the fragment shader, so let me open the frag shader for the tile, and we're gonna have a free glyph frag, right? Version 330 core, so we're gonna have in here. So we're definitely gonna have some sort of a texture, right? Where we, you know, cache the glyphs and whatnot. So let's just call it font, why not? And in the main in here, I suppose we're going to be actually just setting, you know, color, some sort of a color. Let's set red so it's obvious that the shader is working, right? So I like to use the bright colors in the shader so it is obvious that the shader is in fact working. Alright, so this is going to be something like red, like that. There we go. So we have a red color in here. So we have two shaders for free glyphs and whatnot. Okay. So let's try to initialize this entire thing. So maybe we're gonna initialize this thing in a similar place as the tile glyph buffer. So I'm just thinking. So because I want to actually put them in parallel just to see how all of that is working, but I'm not 100% sure if it's gonna be a good idea generally. Maybe I should just go ahead and strip off the tile glyph buffer from here completely. In how many places we actually call to TGB? So here we initialize that, then we set the resolution uniform and some other things. Yeah, there's a lot of things that we're doing here. So maybe it would make sense to sort of extract like all of that stuff into a separate function. And so I can swap between this entire stuff. I don't know. So the function could be called something like render editor into TGB, right? And in here you would accept the TGB and the editor, right? Editor, and on top of that, I think we also need a window to for this thing to work properly. So we'll have to also specify the window. So, and what it does, it basically like you know, renders the whole editor into TGB. So, and then we're going to have a different function called render editor into FGB, which renders everything using FreeGlyph buffer, right? So something like this. This one is not implemented yet. All right. So, and that way we'll be able to switch between different renderers just to see like what's working and what's not. See what I'm talking about? See what I'm talking about? Yes, that's what I'm talking about. So here is the camera, and I guess I can take this entire thing, right? So we set the uniforms and some other stuff in here, and I just strip it off. So editor is not, like a camera movement is not related to the rendering, so I'm not gonna touch it. I'm gonna put this entire thing in here. Yep. So we might as well also put the GL swap in here, I think. Yeah, I think GL swap is gonna be all right. So this is everything related to rendering into the glyph buffer. Okay, so and that means in here we'll have to call a single function which accepts the window, the TGB, and the editor that we're trying to render. There we go. So yes, why fucking this? So it doesn't compile. Oh yeah, because now we're passing TGB by a pointer, not by a value. Thank you, C. Very cool. Right, so I have to deal with this kind of shit all the time, right? Constantly switching from dots to arrows and whatnot. Alright, so and yeah, since it's not a pointer anymore, I don't have to take it by a pointer. Yeah, TGB. Yeah, so this is the pointer now. Not that big of a deal. Anything else we have to do? Oh yeah, an editor. Okay. Editor dot editor arrow. Okay, so is it gonna be enough? Alright, so FreeGlyph render, it's unknown, so that means we'll need to include the FreeGlyph renderer in here. There we go. Is it gonna compile? It's almost compiling, so this one has to be free. Okay, anything else? Window. Alright, so these are just unused variables. Window TGB editor. Window TGB editor. Finally. Right. Cool. I'm super happy. Alright, and let me see if I didn't break anything. Right, so if I try to open this thing in here, there we go. Everything is still working. Everything is still working. And everyone is like, whoa, whoa. Oh, you see? Yeah. Okay. I just have to make sure that I periodically show these pretty pictures so the people stay engaged, because nobody gives a shit about programming. Like, I mean, who fucking cares about it? Like, what the fuck? VIO, VBO, OpenGL, vertex attributes, vertex buffer. Who fucking cares about this nerdy shit? Like, oh my god, shut the fuck up. Just show me the gay editor. Oh my god, this is so cool. Ooh. Anyway, so what I want to do. Yeah, so now we need to basically switch between different kinds of renderers. So we have a tile glyph buffer, and this one is going to be free glyph buffer, right? FGB. So it's also going to be 0 initialized here. TGB, right? Tile glyph buffer init, right? Okay. Glyph buffer init, and it's gonna be FGB, and in here we're gonna be using different shaders. In fact, I'm gonna be using different shaders. So this one actually has to be free, right? So free glyph buffer. So, and in here we're going to be rendering shit into the FGB, right? FGB. Into the FGB, there we go. And if I try to run this entire thing, right, if I try to run this entire thing, it says that this thing is not implemented. Perfect. Cool. So I'm gonna actually be stealing some code from tile vertex render and whatnot. So I suppose the first thing we want to do, we want to actually define the definitions for all of the attributes, right? So we're going to have something like this. So this is going to be attribute definition and glyph. Yeah, let's call it glyph that. And we're going to query replace style with free. Right, so why is it called tile glyph attribute tile? Oh, okay, that makes sense. Yeah. Boom. Okay. So we don't really have a tile, we have a position. So this is the position, right? This is the position. The amount of components in position is 2, but the type is float, right? So if you take a look at the free glyph definition in here, it is in fact float. Okay. So the next one is size. And it's basically the same shit, right? So you have a size, offset of size, float. The character is gonna stay the same, the colors are gonna stay the same, everything is gonna pretty much stay the same. So this definition seems to be working. Let's try to recompile this entire thing. Let's try to recompile. Okay, so does not compile. Unknown type. Oh, okay. So we'll need to include a bunch of OpenGL stuff, right? So tile glyph.h and so let's just put it somewhere here, I suppose. I think that's a pretty good place to put all of that shit in. Is it gonna work? Is it gonna work now? Almost. So initialize field overwritten. Let me see. TGB defined. That's not useful. That's not useful. So we have to have like 5 of them. So my brain doesn't understand what do you want from me. So initialized field overwritten. near initialization. Don't see. I don't see what's wrong. Oh, I see. Okay. I just copy pasted this thing a bunch of times. Okay. Alright, so we have this thing. Okay, cool. Now we just need to perform the initialization. So at first thing we need to do, we need to initialize the VAO. Right. So let me see. So where is initialization? Okay, so we're doing the vertex attributes. I think we're gonna actually copy paste a lot of things in here. Okay, TGB, FGB. So we're gonna have something like this. And also maybe we're gonna query replace style with free. So we have these free attributes and some of this stuff. Okay. We initialize the vertex attributes. Cool. Okay, so what are the... Alright, so we need to have a VAO. In the tile.h, right, in the tile.h we have these two things. I'm gonna put that in here. So I think I'm gonna put it somewhere here. So that's what we wanted initially, right? That's what we initially wanted, didn't we? Okay. So false, let's include the std boolean, right, std boolean.h. And there we go. So we initialize the vertices. So let's try to run the program and see if that does not crash in any way. It still crash. Oh, okay. So render editor to FGB. I think I'm gonna just remove this entire thing because I don't think it's particularly helpful. Let's try to rebuild this stuff. Right, let's try to rebuild this stuff. And okay, so it seems to be working. I don't see any errors from OpenGL so far, so I assume that it initialized everything correctly, right? Because yeah, that seems right. We do initialize the free glyph renderer, and yeah, so everything seems to be working. Okay, so free glyph. Another thing that we need to initialize in here is probably the shaders, right? So we need to compile the corresponding shaders. Let me quickly do that as well. So this is going to be free glyph, actually tile glyph.c. We are initializing the shaders in here. We'll probably also have to have all of these uniforms. We do need time uniform, we do need resolution uniform. I'm not sure about the scale though, but the camera is going to be very useful. Scale only makes sense for the tile, I suppose. Yeah. Okay, so the free glyph. So here is the shaders that we're initializing. Okay, so and in here I'm going to be just using tile glyph.h, and I'm just going to copy paste this thing, and here's the scale and everything. Right, let's see if it's going to work, So compile shader file. Okay, so this thing, if I understand correctly, is part of the GL extra file. Yeah, it's part of the GL extra. Let's actually include it like that. GL extra.h, and boom. Okay, so here is another one. TGB is undeclared, so I think we have to query replace TGB with FGB. Go. Scale is not needed. So we only keep track of the time uniform, resolution uniform, the camera uniform. Right, that's the only important things in here. It would be also nice to have like to keep track of the vertex shader and fragment shaders in here, but I guess that's fine. I think that's fine. Alright, so let's recompile this entire stuff. And it worked, but the vertex shader didn't compile. So we already have a progress. The main program compiled, but the shaders don't compile. So yeah, that's cool. Shaders, and what shader does not compile? It's a free glyph. So, and it says variable cannot be given an explicit location in vertex shader. I forgot some in or something like that, right? So I'm pretty sure I forgot in thingy. Yeah, I did. Okay, so let's actually put in here. All right. So what we have in here? Okay, so everything seems to be working. So the OpenGL complains a little bit. It does complain from time to time, but I don't know. These kind of things seems like very, very minor. All right. So let me see. So in a free glyph.c, we initialize the vertex attributes, we initialize the shaders, but we do also need to initialize the texture, and we need to put some glyphs into the texture. So what I'm thinking is that maybe we're gonna pre-cache some of the existing glyphs, like ASCII glyphs at least, right? So we can pre-cache ASCII glyphs, and we're gonna render only ASCII stuff. And then later on the later streams we can think about how to render more things in there, right? So maybe we're gonna cache more glyphs, or maybe we're gonna have some sort of like LRU cache, which basically removes like glyphs that are not used for very long, right? So we're gonna have a limited amount of space on the texture or something like that. So that would be interesting, I think. That would be interesting. Right. But for now, we need to initialize the FreeType library. Oh boy. So, yeah, before I'm gonna go and initialize, it actually took me like 2 hours just to get to the point where, okay, I'm initializing the FreeType stuff, because first I needed to factor out some of the existing things. OpenGL is super fun. OpenGL is super fun, as you can see. So, but hey, just a second. Chat, look. Gay editor, wow, it's so cool, it's so shiny, it also moves the camera. Oh my god, who fucking cares about VIOs and VBOs? That's fucking nerdy shit. Look at that editor, holy fuck, oh my god, that's so cool. Dab, right? So yeah, what I'm going to do, I want to make a small break. Yeah. I think I should just stop programming and just do this all day, and people will watch me more. I'm pretty sure about that. So, but once we implement, okay, so you know what I'm doing right now? I'm trying to make this editor support FreeType, and once we finish the FreeType support, you know how it's gonna look like? So let me show you. FreeType OpenGL. The text, imagine that text editor thingy with like a panning of the camera and typing and shit like that, but with this font. That's what I'm implementing right now. Yes. So that's gonna be fucking Pogue. Right, this is not a text, it's just like a demo of how it may look like, right, but we need to integrate this thing into the main text editor, right, so, and it's kind of difficult because it's like a FreeType font, and specifically it's a Victor Mono font, right, so if you want to check it out for yourself, you can download it, like a lot of programmers use this font, it's actually pretty cool. And if we manage to integrate that into our editor, it's gonna be really, really cool. And I do understand that all of that nerdy shit is fucking boring. Who gives a shit about all of these VIOs, VBOs, OpenGL, vertex attributes, shaders, fucking layouts, holy fucking shit, all of that shit for us. But if we go through all of this stuff, we may have an editor with this kind of font. And that's gonna be fucking Pogue. So, just saying. Anyways, so I think I want to make a small break and maybe refill my cup of tea, and yeah. Alright, so let's go ahead and try to implement the glyph cache. Hello Deepsinguide, hello. So we're gonna be using the article that I mentioned at the beginning of the stream, right. So I think, yeah, so modern OpenGL tutorial text rendering. So let's take a look at this thing. So I suppose before we go into this entire stuff, we probably want to initialize the FreeType library. Yeah, I think that's going to be the first thing we have to do. Alright, so this is going to be build as sh, right? So, and we're going to add FreeType in here. Right, let's try to build the entire project with the FreeType. Build sh. Okay, so everything is working, everything is working. Let me remove this thing. Let me take a look at LDD. Do we have FreeType? Yeah, there we go. That's a lot of dependency, not gonna lie. So majority of these dependencies probably come from SDL. So your text editor depends on Pulse Audio, by the way. So maybe with the text editor, it would be better to have something like GLFW. But at the same time, I mean, who said that the text editor cannot have sound? Oh, and trust me, Visual Studio Code depends on more things. That's for sure. I wonder on how many things it depends. So if I take a look at the code, I think it's somewhere in OPT VS Code, bin code. So this is the it's even a, yeah, it doesn't even have a proper executable. Okay, thank you. Thank you very much. Okay. I streamed before 2017, but not on Twitch, or at least not actively on Twitch. So yeah, I streamed in all sorts of places, like a website that doesn't exist anymore, like Live Coding TV, and also YouTube and stuff like that. So it was, yeah, all over the place. Yeah, let's initialize the FreeType. So I can probably go into my demo. So it's somewhere like a probe and FreeType. Main.c. So the first thing we need to do in here, we need to save this entire thing in here. So it's going to be ft FreeType. Live Coding TV. Rest in peace, Live Coding TV. Look at what they've done to my boy. Look at what it turned into. The fuck is this shit? The fuck is this shit? Educationecosystem.com. The fuck? Association, the Linux Foundation, Enterprise Ethereum. Holy shit, disgusting. Don't want to even look into that. Absolutely embarrassing. It was such a cool nerdy website. It was like literally like very nerdy website for like programmers to stream their like cringy coding sessions like this one, and it was so beautiful. I really like that website, and it turned into this like horrible, you know, scammy crypto thingy that is, I don't want to even think about it. So I guess it was not profitable, and the original creators just sold it somewhere. I don't fucking know. It's really sad. So, and it was so promising as well. But I mean, it was promising from my point of view, maybe from financial point of view. It was a complete fucking failure. So I don't know. It was so cool back then, at least. So all right. So the first thing we do, we include FreeType, and the next thing, yeah. Probe FreeType OpenGL. So the first thing you need to do, we need to initialize the FreeType library. Decided paywalling streams, but probably not profitable at all. Yeah. I don't know. Maybe I should make my own streaming website, because I'm kind of got used to doing non-profitable activities. I don't know. So I do appreciate everyone subscribing and donating, by the way, but having said that, I'm living a very frugal life. just to make it more or less sustainable. So I kind of got used to this kind of stuff, and I'm thinking maybe this is a job for me, like maintain absolutely non-profitable website for nerds like me. I don't know. At the same time, I'm a really horrible person, so I probably will delete it like in 2 months. So yeah. Anyways, so then we need to essentially yeah, so we initialize the FreeType, so this is the library, and then we need to load the face, right? So we need to load the face. How are we going to be loading the face? That's a good question. So this is how we load it. Then we need to set the size of the font. So I think the size of the font is going to be maybe a little bit smaller than this, right? It's going to be 64. And what we're doing here, we're just preparing the texture and stuff like that, so I think I'm not going to go any further. Right, so we initialize the font face. And let me see if we can now compile this entire stuff. Alrighty, so if I try to run this thing, it should fail because it couldn't find the Victor Monov font. So let's go to the probe. And let's see, so where is the Victor Monov? Here it is. And now if I try to run this editor with Victor Monov, it seems to be working, which is kind of sus. Why are you working? Because I remember I actually disabled all of the things. This is truly sus. Why the fuck are you working? Let me see. Where is the TGB? This is because I stashed my changes because I wanted to show a shiny editor. Yes, that's basically what happened. So I have to go back. Maybe we're gonna actually do a committee and maybe even push it. This shed is not supposed to work. Just saying, it's not supposed to work, but it is in fact working. It is in fact working. So if I do something like that, yeah, as you can see, it is not working. Okay, so let me commit everything. So what's the license of the Victor Monov? Credits. Okay, so I'm gonna put the font here. Font Victor Monov. Okay. So, okay, introduce free glyph renderer. Let's push that right into the. Okay, so I need to re-implement this stuff yet again. FreeType 2. Okay, so let's copy paste a bunch of stuff from the technological demo on FreeType. So this is going to be FreeType, and somewhere in main I'm going to put this kind of thing. So first we initialize that, then we take the Victor Monov, then we initialize the face, and then we set this size. Right, we set this size. We're gonna make it slightly smaller. Okay, so it doesn't complain too much, which is nice. Might as well try to do something like this, just to see if I didn't. Okay, so that looks cool. All right, so this is that, and I'm gonna go to the free glyph thingy, and we're gonna accept specifically FT face, right? So we're accepting FT face, and we're gonna be generating a texture from the FT face. Right, let's give it a try. So, and we're gonna put this face in here. All right, and FT face in this particular case is not known because we need to include the FreeType thingy here. All right, so maybe we're gonna actually do a single compilation unit at some point. We'll see. So conflicting. Oh yeah, this is in fact conflicting because here now we have to do FT face face. Okay, unused parameter. Free glyph. Okay, so here is the vertex attributes initialization, then the shader initialization, and the texture. Glyph texture atlas. And I'm gonna steal the idea from this article. So it has a pretty cool idea on how to do all that stuff, right? So we just generate a texture, and of course it has to be unpacked aligned to 1 because the textures that are generated by FreeType, they used 1 byte per pixel, right? So they're essentially grayscale. So, and by default OpenShell works with the textures that have 4 bytes per pixel, so you have to explicitly say that you want to have alignment of 1. So, and you also need to know the width and height. So to know the width and height, you essentially need to pre-compute the entire thing. This one is rather interesting actually. So here we're iterating through all of the printable ASCII glyphs, right? So 32 up until 127, right, is basically ASCII displayable range. So we load the character for all of these things, and we're taking the sizes, and we determine like how big you want this thing to make, and then we're gonna push all of these things into the texture. So yeah, sounds pretty cool. So so maybe we're gonna have a special function that calculates the atlas size. Okay, static. So the function is going to accept the FT face, right? It's going to accept the FT face, and I suppose maybe it's also going to accept FT uint a glyph index low, the lower part of the index, and then glyph index high, and it will basically generate you the atlas. Maybe I'm not gonna do that, so we're gonna just do that only for ASCII printable range. So I don't know. Atlas for ASCII printable. Size of atlas for ASCII printable, right? So, and this thing is not going to return anything, but I suppose it is going to return the width and height of this atlas. So it's going to be atlas width and also atlas height. Atlas height. So that's really sus. Not sure. Size of atlas for ASCII printable. Alright, so for ASCII printables. So Might as well copy paste this entire thing. Right. So we're gonna have width 0. So, and we're just loading. I might as well. Nah, I think it's fine. Just ft load render, right? Render. So, oh, I suppose it returns error. Okay, so if it's not this stuff. What I'm going to be doing is essentially... This is actually a pretty cool idea. Just put like some sort of login in here. So we're going to be incrementing the width. So bitmap width. But I also want to do something like face glyph. Right, so this is in the face glyph bitmap. And the height, if height is less than face bitmap row, we're going to be setting the height to this specific thing. In fact, Gia, this is also for not monospaced fonts. This is not for monospaced fonts. Yeah, because we're going to be using FreeType for layouting and stuff like that. So it will make sense when I implement it. All right. I might as well save this value as well as needed later on. Well, I mean, obviously. All right. So if atlas width, and it's going to be atlas width equal width, and this one is going to be essentially height. There we go. So that's what we've done in here, right? So Gia, the idea is going to be the following. We're going to put all of the glyphs that we want to render into the OpenGL texture, and essentially we're going to do the usual FreeType rendering, but instead of like taking the bitmap from FreeType and just displaying it, we're going to be pushing the glyphs with the corresponding UV coordinates to the vertex buffer, and then later calling the draw call that in the shader looks everything up and puts everything in the on the screen. So essentially we're going to use FreeType as a helper to put everything in the correct places, but the actual rendering is going to be happening on GPU. And that's how we're going to achieve non-monospaceness. We're going to ask FreeType where to put glyphs, but once we know where we can put glyphs, we can just tell the GPU to do the rest of the things. So that's the idea behind all of that. Does it make sense? I'm not sure if it makes sense. It's like I'm doing a very complicated thing that is very difficult to like explain in few words. Right? Well, I'm not sure if you had written anything specifically to handle proportional font stuff, or the font expert. I don't really have to, because I think the most of the heavy lifting of, you know, non-monospace stuff is done by FreeType anyway. So how FreeType works, by the way, essentially you maintain something called a pen, right? So you place it at XY, right? Then you tell you know, FreeType, I want to render this glyph at this pen. And the FreeType tells you, here is the pixels of the glyphs, and here's the dimensions, here's how you put it, and here's how you advance your pen for the next character. And you keep feeding the characters into the FreeType, and FreeType telling you where to put your pen and how to update things and so on and so forth. So you're constantly having a conversation with the FreeType. What we're doing, we're basically we're basically doing the same thing. We constantly ask in FreeType where I'm putting my pen next, where I'm putting my pen next. And we gathering all of the information about positions, and we packing all of that into the vertex buffer, and we sending it in the GPU, and all of that stuff, all of the rendering, shading is going to be done already by GPU. So we first like pulling off all of the necessary layouting information, and as we know that, we're just so, and all of that heavy lifting is done by FreeType. I'm sorry if I'm repeating myself. It's just like, yeah. So that's the idea, at least. That's the idea. Yeah, FreeType is a weightlifter. Okay. So, let me see. I just need to recover my context because I've been explaining things and now I forgot what I was doing. Yes, I wanted to know the size of the atlas for ASCII printable things. Right, so size of atlas for ASCII printables. Yeah, printables. L1 evicted, yeah, that happens way too often. Alright, so okay, so this one is gonna be just that, and in here we're gonna be just doing something like this, and after that I want to just print this thing like so, right? So it could be something like dxd atlas width, atlas height. There we go. And let's recompile this entire thing, and we'll see what's gonna happen. Okay. Come on. dx. dx. So what does it say? Has no member row. It's because it's rows. Okay, so is everything okay? Oh yeah, thank you for telling me that I have to actually dereference this entire thing. Okay, so... Oh boy, alright, so this thing is unsigned, but this stuff is signed. Okay, so I think I'm gonna do something like ftuint. Right, because I want to stick to the FreeType types, right? And FreeType defines uint and int and so on and so forth. So this one is going to be ftu. It's something like int. There we go. Alrighty. So. There's too many warnings, and I don't quite understand why they're just warnings and not proper errors. Maybe I should turn them into errors, and I don't really like that, but yeah, okay. Alright, finally. So if I try to run this entire thing, and the size, there we go, so that's the size of the texture essentially, that includes all of the... it's a pretty big texture, not gonna lie. It probably heavily depends on the size of the font. We can make it slightly smaller. All right. So yeah, let's actually keep it like 32. All right. So we figured out the size of the whole texture, right? So we know the size of the whole texture. So I suppose the next step is going to be allocating that texture and putting all of the characters into that texture, right? So yeah, so we do that, and then we just put everything. As far as I know, we just set data to 0 because we're gonna fill it up a little bit later. And then we repeat the process, loading all of the glyphs and just putting them all in there. Okay, I suppose let's just go ahead and do that. So init vertex attributes, init shaders. So this is a glyph atlas index thingy. Yep. So I suppose we're gonna set the active texture to GL texture 0, so it has something to do with the texture units, the active texture units and whatnot. Then we generate the textures. We're gonna generate a single texture inside of the FGB. And what we're gonna put in here, I suppose, let's call it glyphs texture, right? So this is gonna be like a literally glyphs texture. Right, and then we're gonna bind texture. What the fuck is this? GL bind texture, GL texture 2D, and we're gonna be just binding this entire thing in here. And we also, as already said, need to set up the alignment, because by default OpenGL assumes the pixels to be 4 bytes, but we have pixels of 1 byte. Right, unpack alignment is gonna be 1, and then we're just essentially, yeah, initializing everything. So texture image 2D. There we go, GL texture 2D. Might as well want to pull off. Yeah, let's actually pull off the signature of GL texture image 2D. GL text image 2D. There we go, and let me grab this entire thing. Yeah, that's a lot of shit. That's a lot of shit. I like to go through all of the parameters just in case, just to, you know, confirm that everything's okay. So the target is in fact GL texture 2D. The level is 0. It has something to do with meep maps. We're not using meep maps for this one. So GL red, we have only one component, right? So as I already said, it's a grayscale. In case of one component in OpenGL, you can just set any component. Usually it's just red because it's kind of easier. So here we'll have to put the atlas width and height, right? So it's going to be something like atlas width and atlas height. So border, I'm not sure if anyone is fucking using the border, so it's usually 0. So the format is basically just an alpha, right? So, and then the element, the type of the element of the component is unsigned byte, right? And the data, the pixel data, we're gonna set it to 0, indicating that don't fill it in, don't initialize it. We're gonna initialize all of that later. Mods, ban this person, permaban. All right, so we initialize this texture, and the next thing we need to do, we need to repeat this entire process of just putting everything into that texture, right? All right. So, but we also need to maintain this X thingy. So it's actually a joke. So, but yeah, thank you so much for banning. Yeah. Thank you, Jay. Really appreciate it. I just didn't expect that anybody will take it seriously, but I guess, yeah. All right. I guess I should stop making this kind of jokes, because I do understand it's kind of difficult to understand when it's a joke and when it's not a joke, and it's just like, yeah, should have not made it. All right, so anyway, let's continue with the development. I just okay. All right, so if this thing is not defined, we're just doing GL sub image to D. Yeah. GL sub DL texture. Is it text or texture? Sub image to D. So let me see. Gel texture 2D. So the level, okay, so the offset, so X is gonna be that, but in terms of Y, it's gonna be always 0. So width and height is gonna be always something like face, glyph, bitmap width, face, glyph, bitmap rows. The format, yet again, has to be alpha, right? GL alpha. The type, GL unsigned byte. And then it's going to be face, glyph, bitmap buffer. Bitmap buffer. That's essentially what we have in here. And then we're updating the X, bitmap width. Alright, so this is how we put in all of the glyphs in there, right? So we prepared the texture and then we put everything in there. So since we already sort of inlined this entire thing, maybe it would make sense to actually inline this function here as well, right? Because there's no reason to like not do that. Like why am I even doing that? Right, so and in here width is going to be atlas width. So this is going to be height and this is going to be height. And initially both of these things are going to be 0, right? So both of them. Size off, and let's get rid of this stuff. Right. Okay, so we prepared everything, we put that, because I'm not going to need this information anywhere else, so I can just use it in place. So it doesn't really matter that much. Okay, is it going to compile? Okay, cool. So has no member glyphs texture. Okay, so that means I need to actually put it in there. Glyph texture. GL uint glyphs texture. So that's what we're gonna put in here. Okay. So oh yeah, it's not really G. It's a face glyph bitmap width. Come on, you can do that. Alright, so it kind of worked. So that means it initialized the texture. Okay, so I think we initialized the texture technically. We technically did. And I wish we could somehow print something. At least, I don't know, we'll see. But let's try to print that texture specifically. So I'm gonna go in here. And here, we're gonna be doing the following thing. I'm gonna do gl draw. Right, so free glyph.c. Maybe it's gonna be tile glyph. GL draw instance. Yeah, there we go. So it's gonna be trail strip, and in here I wanna actually render. Man, I think I just need to draw arrays. Right, I'm drawing the arrays, and it's gonna be just 4. And let me try to run this entire thing. So if I did everything correctly, it should simply, yeah, it should render the red one, which is precisely what I wanted. So in a shader, in a free glyph shader, we can change the color, right? So this is going to be something like this. Let me see. So it's going to be green now, hopefully. It is green. Let me try to change the following thing. We should have UV coordinates, right? So this is going to be vertex. So we're going to in vec2 UV. And then what I'm doing here is simply texture font UV. Let's see if we do have the texture in here. Do we have a texture in there? We don't. That's beautiful. That's absolutely cool. And I wonder why. Is it because it's alpha? It could be because it's alpha, actually. So, can I just take... Yeah, we set it to alpha. That means it's somewhere like W. And can I multiply this entire stuff by something like... I mean, we can just set it to vec4 1 1. Right, and this is basically the alpha. Please work. It didn't work. Yikes. All right, so I wonder why it didn't work. Didn't compile, maybe. Haha, very funny. Okay, so let's try to troubleshoot this thing. I wonder if RenderDoc can help, maybe. So this is the nearest. We did everything, we bound everything. So this is the wrong one. We need to take a look at the free glyph. Alright, so here is that thing. It should just work, but it simply doesn't. Maybe I could do the same thing as I did in my tile glyph, because in my tile glyph I just set, I think RGBA or something, so we initialize the texture. Oh shit, no, in my demo, FreeType OpenGL, right, so when I was setting the texture, GL texture something something, I actually set both red and red. So might as well actually do it like that, red and red, right? And that way I can probably use this thing directly in my shader. So it's gonna be frag. It's not gonna be alpha per se. It's gonna be just red. Let's try to recompile this thing. So FreeType frag. Interestingly enough. So the texture is just not sent properly at all. Can we just try RenderDoc? I tried a RenderDoc already, but it never worked for me. I just want to see if the texture even exists in there. Let's give it a try to RenderDoc. I'm pretty sure it's not gonna work again. Every time I try this shit, it never works. Never works. I should actually run it asynchronously. It's okay, Celine. We're gonna find the problem. Don't worry about it. Everything is gonna be okay, and we're gonna have a gut coder moment as usual. So don't worry about it. So everything's gonna be okay. FEX RenderDoc, and why I keep doing that in asynchronous mode and Emacs doesn't show me anything. Alright, so this is gonna be something like that, and RenderDoc bin q render. Alrighty. Launch the applicazione dead, and let's just launch, and yeah, it just doesn't work. I can try to capture frames immediately and it's just like doesn't freaking work. Doesn't capture anything. Doesn't capture. Yeah. Alright, so probably because of OBS or something like that. I don't even know. So, but this is something that we'll have to figure out ourselves, unfortunately. This is something we'll have to... Wait a second, so we're doing the loading, but isn't loading enough? Because I'm pretty sure... load the render. So you load the character, but is it really enough? It might be not. I need to make a small break. My brain is just freaking melting. So I'm gonna make a cup of tea and then we're gonna continue. Right. So let me see what we got. We need to understand if the texture was even created in the first place, right? if you know what I'm talking about. Right, mate. So if I go into the free glyph.c, so we activated this texture, we generated a single texture in here, we bound it, we set this stuff, we prepared this stuff, and hopefully then we initialized everything. So I didn't see any errors in here whatsoever. So I might as well go into the debugger and just do gdb dead, and let's break at free glyph, please see, and it's gonna be 110, and I'm gonna run this entire thing and enable the TUI, and let's see. So oh shit, oh fuck, oh shit, let's actually break at 123, continue, and let's take a look at the atlas width. Right, so atlas width is that, and atlas height is all right. So everything seems to be more or less correct. So we initialize the texture and stuff like that. Might as well print the glyphs texture just to see if it is correct. It seems to be correct. I don't see any particular problems in here. All right, so we loaded the texture, right? And I can take a look at the face, glyph, bitmap, buffer, and it is null, of course. This is a freaking classic. Freaking classic. Didn't load the glyph correctly. Thank you, article. Very freaking cool. Right, so don't use this article because they're like don't know what they're doing. Okay, so but I think we can quickly fix this situation. I mean, the article is all right. I'm joking, of course. So it's just like it feels a little bit incomplete, but maybe it is complete if you read the entire text. But I don't read text. Who reads that? Come on. So how do we load the thing? So ft. So where is the stuff? Canvas for text. So here we calculate the size of the canvas, then ft load glyphs. Yeah, so you only load it, but you're supposed to also render it. That's the thing in here, right? You're also supposed to render that, mother flipper. And it looks like they forgot about that. Did they? I think they forgot about that. Yeah, so they only load these things, but they never render them. And that's incorrect. Free glyph.c. So so we load the character. So here we actually load the glyph, but here we load character. After we loaded character, so I might as well actually do something like. So let's crash if we cannot load this thing. Fprintf stdr could not load glyph of a character with code D, and this is going to be something like I, and it's going to be 1. Right, so after that we're supposed to render the glyph. Render glyph face glyph ft render mode normal. Right, and here we're gonna be just copy pasting this entire thing. Come on, man. Could not render glyph of a character with code that. Cool. Right, and then we just put all of that stuff in here, and let's try to recompile this entire stuff. This is not how you recompile the entire stuff. Thank you very much. So let me see. Okay, so everything seems to be okay. So this is going to be frag, and can I just use this thing to see if we've got the fuck? The fuck? Alright, so it didn't work. We can try to GDB that thing one more time. One more time. Wait a second, 32 is a space. Well, I mean, no, it doesn't change anything. So in case of a 32, it's supposed to be null, I think. I think I'm Peperba. Alright, so if I break free glyph.c 140, right, 140, and I run this entire thing to enable. Alright, so if I print face glyph bitmap buffer, it is absolutely empty, which is fine, I guess. And we can take a look at the face glyph bitmap width. Oh. Who wrote this tutorial? This is not how you're supposed to get the size of the glyph. I just realized that. It's... Well, I mean, maybe it is. Okay, so let's actually try to go to the next iteration. So maybe on the next iteration, it's gonna be a little bit better. So, all right. So if I print glyph bitmap buffer, all right. So it does have something at least, and in terms of width, it's 5, and in terms of height, it's actually it's rows. It's 24. All right. So that's fine. I guess. And also, if I take a look at the ASCII of that thing, 33, it's okay, that makes sense. That's why it's so thin, right? So that's why. Okay, so that's fine. Everything working fine, but it's just not updating the texture whatsoever, if you know what I mean. It's just like not doing anything, and I wonder why. Oh boy, oh boy. And I wish I could confirm if there is anything in that texture, right? If you know what I mean. Is there anything in that texture? What is going on? What is going on? Okay, it could be something with the fragment shader. Alright, so if it's only a red component, maybe... How do we handle that in our demo? So FreeType OpenGL, so it's gonna be shaders, fragment shader. So when okay, so I actually take only the red component. Maybe that's precisely what I need to do in here, and just like use something like vec4 0 0. That's what I have to do in here. It's taking me way too much time to troubleshoot. I don't like that. This is so painful. It's like something dumb. It's something very, very dumb, and I cannot find it. Fuck. It's just painful. Okay. I literally don't see it. I literally don't see it. So it's way easier to maybe generate it on GPU, but generating on GPU will require scratching this entire code and making it from complete scratch. Scrapping, not scratching, scrapping the entire code. So did I make any mistake in here? So X offset, Y offset, width, height, format, type. There's no problems in here. There's just it's fine. Can we dump those glyphs? Let's try to dump those glyphs and see what's going on in here, you know? So I'm gonna include stb image. So we need stb image right. Git nothing stb stb image right. So here is that. It's gonna be a row. I'm just gonna double get. So that means also we'll have to include this entire thing. I already have stb. Oh, it's a different source code. So this is gonna be stb image, image right, and in here in the glyph.c we're gonna be including this shit. Okay, so where is the stb image right? I don't see. Am I going crazy? I'm going crazy, I don't understand. Here's the stb image right. Okay, I am going crazy. So, oh, and all of these annoying warnings, of course. Okay, so we need to go through them. What's going on in the chat? Okay, so we need to dump the glyphs that we just generated, right? So stb image right, stbi image png, right? So it's gonna be something like this, but we also need to have the file name for that. So this is gonna be file name 255, 56, whatever. Sn printf. File name, size of file name, so glyph d png I, there we go. So then we're gonna put a file name in here. Width is essentially that thing. So we're not calling this on every frame, right? So it should be fine. Should be fine. Rows amount of components is 1. The pixels is the buffer, right? So the pixels is the buffer, and the stride is the width, right? The stride is the width. And if this thing did not succeed, we'll have to throw an error. Printf std error. Error could not save file. This file name and just exit with 1. There we go. Okay, generated a bunch of glyphs. All right. Well, here they are. I can clearly see them. I don't see any problems in here. So here are all the glyphs. All of the ASCII glyphs that you want to have. Literally don't see any problems. So so that means it's not problem with generating the glyphs themselves. It's about putting them into the texture. Right, so, and what exactly, so the problem is in here, straight up. Yeah, the problem is straight up here. And I don't know what causes the problem. So because the glyphs are fine, so it's just perfectly fine. Might as well just, you know, disable this thing for now. I had a similar issue. No, that's precisely what we're doing, so I didn't see any problems. So we call this thing at least once, so that definitely makes sense. And we set the data to 0, and then we call several times in here. GeoPixel store. So that is really sus. Why? This is so annoying. This is really annoying, holy shit. It's just so bad. Submod incoming, by the way. Alright. Okay, so there is another interesting idea. Maybe the texture is not properly working at all. Frag. So it's a uniform sampler. We're taking this entire thing and okay, let's try to load an actual image instead of this entire thing. So I'm gonna just get rid of this entire thing. Right. And we're gonna load the image in a similar way as we do that for the tile glyph. Right, so stbi load. We're gonna just replace this entire thing like that. Right. Font texture. All right, so here we're gonna use query replace. Yeah, it's gonna be texture. PNG. FreeType. Like so. FreeType like so. So this is. I should have actually done it like texture file path. Const char texture file path. So texture file path looks good to me. And query replace tgbfgb. tgbfgb. So and that should be. So let's go through the compilation errors. Let's go through the compilation errors and whatever. Could you please already work? So free glyph.h glyphs texture. Glyphs texture. Come on. Bind texture. Glyphs texture. Is that it? I hope that's it. It's working. So the texture is passed correctly. The problem is specifically in the GL text thingy. And I don't know why. All right. So it's specifically in here. GL sub image. Okay, so I know that everything's okay in here, right? So I can remove this thing. Right. What if I don't do any of this shit and I just pre-allocate a huge array and just fill it with bytes or something like that? Right, so we're not going to be doing any of this stuff. Right, and in here, I'm going to just malloc size of uint 8t multiplied by the atlas width, atlas height. So there we go. And uint 8 pixels. Right, so here are the pixels. Right, and I'm going to do mem set pixels. Can I just set them to 155 to all of them? Basically the size of just this thing. All right, so so we're setting this thing. All right, so this is the pixels, and what I want to put in here, I want to put the pixels in here. Right, so if I try to do this thing, is it going to work? It is not working. Okay, so the problem actually starts not in sub image, but specifically here. Right, so we're trying to set this thing. I might as well actually go like this, less than atlas width atlas height plus I. And so it's going to be pixels I 255. Right, so I want to make sure that it is doing what I'm thinking it's doing. Okay, the problem is straight up in here. Where is the problem? That's the main question. Where is the problem? So we can try to print f this kind of thing. Atlas width, atlas height. Show me the size. Wish it was a little bit faster, but okay, the size is all right, but still does not work. Alright, so let's compare these things. We generate a single texture, then we bind it. We never set any of this shit, didn't we? Okay. This article is just wasting people's time. I swear to God. This article is literally wasting people. Like, don't use this article. It's horrible. Holy fucking shit. So it's complete. It's incomplete. You can only use it as like main idea, I suppose, but you cannot use it. The code is completely fucking broken. It's just unusable. You have to fix it yourself. All right, so okay, so this is gonna be null, and I suppose that's the problem in here, right? So we can now enable this entire stuff. So let's not save the glyphs, so we don't need to save them, right? Let me see. Freaking finally! Holy shit! Oh, yikes! That's the biggest fucking yikes I had to deal with. Holy shit! Oh, so painful. All right. wasted so much freaking time. Oh my god, like I didn't know that if you don't set these parameters, it will just silently fail. Alright, who would have thought? Right, OpenGL, am I right? So, okay, what's the next thing? The next thing is actually caching all of the characters info. Right, so we made the atlas, right? We made the atlas and now we have that atlas on the GPU. So we need to store this information like advance, width and height, left and top, and also we have an offset of glyph and texture coordinates, which is, well, yeah, I guess it's fine. So in the for loop where you upload the glyphs images to the texture, yeah, so we also need to put this thing in there. And when you're rendering the text, right, so we essentially, yeah, what's funny is that we don't even call to FreeType anymore. That's cool, because we cached all of this information now. Alrighty, so I think I need to define this structure in here. So free glyphs. So we have a glyph in here, so we have to define it like that. Type def. Glyph info. So this is a glyph info, and well, maybe it makes sense to credit this entire thing. So I'm gonna just put this thing in here. So here's the glyph info, and think about that stuff is that I want to put it somewhere, maybe here. So this is the glyphs. And on top of that, we're gonna have a glyph info, glyph infos, and we have, how many of them? 128. Well, we can use 128, sure. So basically, some of them are gonna be completely empty, and that's fine, I guess. I guess that's fine. So this is more of a matrix. Metric. Is this a metric? I think it's a metric. Yeah. Metric. Let's actually keep it like that. Glyph C, and this is where we cache in everything, right? Also, I think I need to do something like this and crash. Here. Cool. So, and what the fuck is this? This is such a weird article. It's just like a bunch of shit like thrown together. Like it's just like, yeah, so bad. Well, I mean, it's kind of helpful. Like it's not really useful for beginners. Like I can probably fix it myself, but it's just like really get into that. It's literally random chunks of codes like thrown together and whatnot. So this is W. What is this? All of this shit. Holy fuck. Yeah, just like put this thing in there and just like, yeah. So that's literally the article. Okay, face glyph. Yeah, something like that. So we have this thing. And what is the freaking width? Width, I suppose. Oh yeah, width is that stuff. So that means here I also need to set it to float. And what is X? X is a current pen. In the loop where you upload the glyph images to the texture. Oh, okay, so that means I have to do it somewhere here. Yeah. So, so we might as well put it like that. So because we do have an X in there, yeah, we maintain the X, and then we just do that. So here's offset. All of that makes sense. Okay, all of that in fact makes sense. Is it gonna compile, please? Thank you very much. Okay, almost. Oh yeah, and I have to replace the C's with metrics. So this is going to be FGB metrics. That's what we're doing here. Let me actually combine all of that. Fuck me. Metrics. Oh, right. So this one is atlas width. Come on, you can do that. All right, finally we compile that and we have all of the necessary metrics. Cool. So now we're trying to render lines of the text and whatnot. So we provide X and Y, and what is SX and SY? What the fuck is this? Why do you need that? You essentially only start from a particular point. So, oh, it's a scale. Fuck. Advance the cursor to the start, blah blah blah. Okay. Cool. So I suppose we need to implement some, like the rest of the functions that pushes the glyph there, and synchronizes the buffers, and so on and so forth, and performs draw call and whatnot. Right, so yeah, the main heavy lifting stuff is already implemented. So we need to implement these small functions. Like clear is super easy to implement, right? You basically take the glyphs count and set it to 0, and there you go. So this is how you clean the buffer. So when you push the thing, we check that you have enough space in the buffer. So glyphs count. Come on, Emacs, it's not that hard. Just autocomplete. Okay, so less than free glyph buffer cup. Right. So, and you do, it's actually FGB. So glyphs, this stuff, plus equal to glyph. There we go. So, and that what we did in here. So I can steal some other stuff in here. For example, synchronization, right? So this is going to be synchronization, pretty straightforward. So this is basically we're sending the glyphs into the GPU. So query tgb fgb, and this one is a free glyph. There we go. And the draw is also pretty straightforward. It's just like instance draw, using the amount of glyphs that you've got. Right, so FGB, right, and does it compile? Hopefully that shit compiles. Okay, now the most important stuff. We need to learn how to render a single line, right? Single line, free glyph buffer, render line sized. We provide free glyph buffer, FGB, right? So we also provide the pointer to the text, right? The size of the text. Then, in this particular case, we probably don't have to provide anything. We could provide the position where it is located. So this is going to be the position. That's pretty much it. And we can also specify the foreground color and the background color. Right, there we go. We can have a similar thing for not sized line. Right, so it's simply going to not accept the size. Right, and that's the two functions that we'll need in here. Alright, so free glyph, I'm gonna put everything in here. This one is not implemented yet, but this one is gonna be implemented in terms of this function. Right, so, and we're gonna put it in here. So FGB, text, the size is strlen text, the position is gonna be that, the FG is gonna be that, the background is gonna be that. There we go. So how are we going to be implementing this stuff? So that's pretty much what we're doing here, right? We're going to be iterating through each individual text thingy. I'm not sure why the fuck you need point in here. It's kind of weird on that one. I think I know. So it puts all of that shit into the buffer and whatnot, yeah. So buffer data, coordinates, and then you're supposed to write that in a shader. Yeah, that a lot of information in this article is straight up missing. It's just like basically outlining the concept, but you have to know how to do this kind of shit. Luckily, I have enough knowledge to actually pull that off. This is actually quite cool. I'm really glad that I have enough knowledge. So let me see. So we also need to know the atlas width and height, which is quite important, right? So we do keep track of the atlas width and height in here. So I probably need to move that thing into the state, right? So it's going to be somewhere here. Let's put it like this: atlas width and height. And because of this, we're gonna just remove this thing. Let's go through the compilation errors. Yeah, you don't need this kind of stuff in here. Come on, man. Okay, show me all of the compilation errors, please. So FGB, right, so this is FGB, and this one is FGB. Any other atlas width? Another FGB, atlas width, another FGB, atlas width. Okay, that's it. Okay, so, and it has a bunch of warnings in here, unused variables. That's totally fine. All right, so let's take a look at what's going on in here. So I suppose we start with the pen. So this is essentially the pen where all of that shit starts. So then, based on the character, we find the bitmap left and top, and this is how we calculate the second point in here. And then here is the width and height, and we advance the character in here, all right, and then the coordinates. Okay, so I do understand what the fuck is going on here. So x, y is essentially the position of the glyph where it starts, and s and t is... this motherflipper generates the... Oh my god, I see what it tries to generate in here. We'll have to generate UV coordinates ourselves. Fuck. Okay. Shit. Alright, so I made a actually critical flaw in the design of this thing. I think this thing should not be a character in here. So I think this thing should be like UV coordinate, right? So we have a position and size, and then you need the position and size within the UV coordinates of the texture. Oh shit. This is actually... Okay, vector to F. So this one is going to be UV position, and this one is going to be UV size. Right, so the vertex attributes are completely different in here, so that's going to be the glyph. So, yeah. Alright, so let's go ahead and do that, I suppose. So size, this one is going to be UV position, UV size, and let's just go through the compilation errors. Okay, so UV position, right? So in the case of the UV position, right, it's a UV position, the amount of components is 2 and the type is float. And similarly, we're gonna have UV size, right? So this is gonna be the size, this is gonna be the size. There we go. Position and size should be enough. And I suppose now we have 6 of these things, right? All right, so yeah, I really like how easy it is to just modify the attributes in my system. You just change the enumeration and that's basically it. All right, so now we're gonna be computing UV coordinates. So the complexity of this code is that it generates like a triangles and whatnot. It's just like, yeah, it literally generates triangles and shit. It's quite funny. Okay, so advance the cursor to the start of the next character. So SV, skip coordinates. And in here, okay, so this is the TX. Okay, this code like requires quite a bit of adaptation. It's not gonna lie, so maybe it would be easier for me to even implement it from scratch. But who knows? We'll see. Okay. So we're gonna be iterating through all of the characters, right? So we're iterating through all of the characters. Text size plus I, there we go. And for that character, I'm looking up the metrics. So FGB metrics text I, there we go. And these are the metrics that we have. Glyph metrics, there we go. So this is what we got. So in the metrics, okay, so we have a position essentially, right? We have a position, and I should be able to construct a new like x2 position 2, right? So it's going to be vec2f, and in here I take the position x plus metrics bl. I don't have a scale in here, so I'm not gonna even apply it. Right, and then the second one is going to be position y minus metrics bt. So that's the position 2. Right, so we have a position, might as well actually call it position 1, right? So yeah, let's call it position 2, whatever. So then we're gonna have a size. So here is the size. Well, the size is literally that. Not sure if size is very important right now, so I'm not gonna do anything much. So advance the cursor to the next character. Not sure what is x2 and x1. So x2 is effectively where it starts, and this is the coordinate of this thing. Oh yeah, okay, so essentially I see. You need to have width and height. Shit. You really need to decode this thing. All right. So I do kind of understand what's going on. It's just like it's written for a completely different style, of rendering, not the one that I'm having in my case. Right, so it like requires a bit of adaptation. Right, so that's the problem. Metrics BW and height BH. Alright, so you have that, then we can quite easily adapt this thing, but not really. So the position that we're gonna have in a glyph dot h, where is the glyph that I need to push in there? So yeah, so we need to be able to put that. Right, so this is the glyph. So this glyph is going to be initially something like 0. Alright. Glyph dot. So, and Why the fuck are you doing that? Wait a second. It does y2 is minus y minus c. And then when they apply y2, they negate it back. What the hell is wrong with it? This is such a bad... Like, what the fuck is going... Why? Just why? Holy fucking... Okay, why the fuck are you doing that? Like, it's just such a bad article. I should have actually, like, thrown away this article in the first place and just implemented everything from scratch, but maintained the idea. This is just straight up fucking weird. This is the weirdest code I have to deal with. Okay, so vector 2f. Why are you doing that? Oh my god. So on the size, right, in case of a size, maybe... Yeah, so this is going to be W and this is going to be minus H. So that's basically what they try to achieve here. So here's the position and here is the size. So UV position is rather interesting. So UV position is vector F matrix Tx. This is X, but Y is going to be 0. And in terms of width, is going to vector 2. The width divided by atlas, so that means it's going to be matrix BW, TG, FGB actually, float, like this, and then the same shit but for the float. Okay, I see what you're trying to do in here. Alright, so BH height. And essentially in here, I might as well just do something like this. Boom. So that's basically everything I've done. And I think after that we're ready to just push that glyph right into the repo. Alright, so... so we're pushing glyph. Glyph metrics, so it's unknown, right? Metric, it's a single one, okay. It's a single metric. Okay. Come on. CGB. FGB, sure. Okay, cool. So, yeah. Hopefully it will generate the correct thing. No! This is not enough. This is just like generating all of this shit. It's just like have nothing to do with the actual thing we want to do. We're not getting even closer to having an editor with this kind of shit. Okay, so here's that. And what I want to do in here is essentially make a sequence of calls to the free glyph renderer. Everything is so unnecessarily complicated in OpenGL, like holy shit. Okay, so we do FGB, so we clean the buffer, right? We clean the buffer. Then we render the single string, right? We just render the single string to FGB. So that string is going to be hello world, right? Hopefully hello world. Vector to F, and it's going to be at 0, right? So this is going to be at 0. The foreground color, let's go to FG color. The background color, I suppose, for FS is going to be 0. but the foreground is going to be vector for fs1, and that's basically what we're doing here. After that, we want to synchronize this entire shit. We're synchronizing the buffer. All right, so sending all of the glyphs that we cached in there, and then we perform the draw call, drawing all of the glyphs. Right, and even that's not enough. I think, oh no, that's actually enough. Okay, so that's what we need to do in here. Okay, and let me go through this stuff, because this thing is called FGB. All right. All right, but weirdly enough, it did a thing, kind of a thing. Let's go into the debugger and do gdb dead, and we're gonna break on this thing, run it, and let's take a look at what we have in FGB. So it is too big. Let's take a look at the glyphs count. How many glyphs? We have 12 glyphs in here. Right, if we take a look at some of these glyphs, right, so add FGB glyphs count, all right, so here are all of the glyphs. We know their positions, we know their sizes, and also UV positions and UV sizes. So this data looks actually correct to me. This data looks more or less correct to me, right? And of course, foreground color, as you can see, is white, and background color is completely transparent. So this is, yeah, basically what I would expect to see. So this is what we are about to send to the GPU with GL buffer sub data. All right. So now we need to make the shaders, appropriate shaders that can actually handle all of that shit. So let's go into the shader free think vertex, and we actually changed the layout of the vertex attribute, so we have to you know, take that into account. src freeglyphs.h. So in here we have a position size, but we don't have a ch anymore, right? So this thing is vector to UV position, right? Then this is the third one, UV size, right? So UV size. The fourth one is background, and the fifth one is the background. Okay, there we go. So this is the data that we're sending to the GPU, and we need to generate an appropriate quad using that data. All right, so we have a UV quad, right? So the first thing we want to do in here, so it's 1 by 1, nothing particularly special. If I multiply it by size, the shape of the 1 by 1 square becomes that specific size, nothing particularly special. Then I add the position, and that makes it located in a particular place. So, and after that, I want to do camera project, right, to project this entire thing to like the screen, right? Can I steal that stuff from the tile glyph thingy? So I do remember it's actually called project point. Okay, let's call it project point then. Well, I mean, I kind of like camera projects, so fuck that. So that means I'll have to do it like this. Camera project. So here's the point, and we do need to have two uniforms in here, right? So it's going to be uniform vec to resolution. So this is the resolution and the camera, and I think we do pass them. We do accept them in the renderer, right, when we initialize this entire thing. So this is going to be camera. Yeah, here they are. All right, so we map this, and we can just put this entire thing into the fragment shader and forget about it. All right. So, but now we also need to forward all of these things to the fragment shader. So let's do it like this. So this is going to be UV. This one is going to be just straight up out. But we also want to sort of like, I don't know, prefix it with something. Glyph UV position, glyph UV size, and also the actual UV and background color and whatnot. So yep. So we already initialized UV, so there's no need for that. So, and I'm gonna grab this stuff. So it's gonna be equal, and what we make it equal to? Oh my god. So freaking painful. Holy fucking shit. Okay, so now I should be able to do something like this. Finally. Okay, so we're passing all that shit into the fragment shader. Okay, so free frag should also accept all of that shit in here, so this one's gonna be in. Alright. So this is that. We transform everything, position everything appropriately. Alright, and now when I query the font UV, I actually do something like plus position. Right. So it's actually glyph position UV. Right, so I need to start searching for the glyph somewhere here, and then add the position in accordance to this UV in here. So that means in here we're gonna have something like T, and that's precisely the place where we have to search for a pixel in the texture, like this. So right now we're not gonna do any background and foreground color. We're gonna do that later. So it's gonna be a red one, at least for now. So it could be also inverted for whatever reason, but we can probably fix that quite easily, I hope. So inverting this kind of stuff could be done on a level of UV coordinates, and we make the UV coordinates at CPU, so maybe we can flip all of that on CPU as well. Shouldn't be that hard. So there's a couple of things that we need to go through. Unused variables, so that's fine. I'm gonna do something like void window. Okay, TGB is unused. So array subscription has type character. So is that something bad? I can just make it an integer, right? Alright, so it kind of did something, but it definitely didn't work. Right, so at least we tried, right? So let's go to the main, and so we clean everything first, we render the line, we synchronized the buffer, and we draw the thing. Okay, so, but the question is why it didn't display anything whatsoever. I have no idea. So we can try to maybe take a look at the fragment shader, right? So, and inside of the fragment shader, I can set something like vec for 1, right? Just to see if it even like tries to do anything. And it doesn't even try. So cool. That's very interesting. So that means maybe it even places them in terms of like vertex coordinates incorrectly. So here we have a position and size. So we do camera project. Oh, okay, yeah, I know what's up. So we need to set the camera in resolution. Yeah. Okay. So you see, I troubleshoot that without any render doc. Well, I mean, render doc would be helpful in here, but it doesn't work for whatever reason. So here we set the camera, so resolution uniform. So here's the resolution. And the camera, maybe we can keep the camera like 0. At least for now, we need a resolution, I suppose. So FGB. So I'm gonna put this stuff in here. So that takes the window, and this one could replace TGB with FGB. There we go. Need to recompile this entire stuff, of course. Build.sh. And it did something. Oh my god. well, we can see something, which is cool. All right, so now something is visible and something with the vertex, something completely incorrect. If I remove the entire thing, so nothing changed. So it's not about the camera though. It's not about the camera. So position and some other stuff. Did I update the... I see. Mods. Okay. Alright. Render line. Okay. So free... my brain doesn't work. Free glyph.c, right? And yeah, I don't update the position, so I just need to update the position first. So this is how we're gonna be doing that. So here it is, and in here, effectively, I do metric. Scale is not needed in here. Position. There we go. So that's how we update the position. And let me see if it's gonna work now. Okay. That looks like a freaking text. If I ever seen one. 32 is 32. So when we initialize the font size, let's actually do 128. Okay, so maybe 64 would be a little bit better. Unfortunately, while the problem with these kind of streams is that they're very difficult technically, and until you get to something interesting, there will be enough time for a lot of people to leave. So we're about to have something actually interesting, and we keep losing people, unfortunately. It's really hard to do these kind of streams. Like, so I guess you have to like prepare for this entire thing. You just have to show the ready thing, but what's the point then? So I don't know. All right, so we actually, like, those of you who actually stayed long enough, you're about to witness something really fucking cool. Right, so all of you like waiting actually is about to pay off, hopefully, if we don't hit any roadblocks. Because we're starting to at least place the characters correctly. This is already something interesting. So, and now in a vertex shader, like in a fragment shader, I'm about to try to query the texture. Right, I'm about to try to query the texture. Let's see. Some of the things I like feel they're cut off a little bit. Oh, okay. But yeah, that's pretty cool. So yeah. All right. Not bad. Not bad at all. So maybe we should actually set like a filter, proper filter for the texture. Just a second. I'm gonna go to the free glyph and. So what's the filter? We're using nearest. Let's use linear. Linear. This is not the coolest part yet, chat. This is not the cool part. Like, don't worry about it. We're about to get there. All right. So let's say that looks a bit better with the linear interpolation. Looks a bit sus. It looks a bit like cut off. I don't know why. But. Not bad. Not bad at all. Okay, so let's actually try to yeah. So we're about to do the rainbow, of course. We're about to make this this editor hella gay. So let me see. Tile frag spoilers. Yeah, sorry for the spoilers. All right, so we're gonna do it like this, and. We also need the time, I suppose. Right. We also need to put the time in here, and so the rainbow Yeah, rainbow looks fine. Oh yeah, we definitely need this kind of shit. Right, so this is gonna be that, and I suppose I simply can take this thing, a rainbow, multiply this thing, rainbow. Okay, so now I forgot what I was doing. I needed to also forward the time. Yeah, I need to also forward the time. So how are we gonna do that? TGB, right? So here's the TGB. Time. Here it is. That's what I wanted to do in here. Might as well also set the camera uniform in here, but maybe a little bit later. So it's gonna be something like that. Time uniform is that. So this one is gonna be FGB. There we go. All right. So resolution undeclared. So this is the fragment shader. Okay, so let's just have a resolution then. And do you also need? Yeah, it's not initialized. Okay, so I'll give it a try. Okay, that didn't work. GL uniform program not linked because why? Resolution declared as float and type vector. Oh, okay. So thank you so much for telling me. Alrighty. Yeah. Now we have this shit. Cool. It's pretty cool, huh? Victor Monov. Okay. Next thing, boys and girls. Next thing. We need to render the whole state of the editor. That's what we need to do. Also, I think we need to go and do the camera, right? We need to constantly update the camera. We do update the camera in FGB. Right, so... so we do clean, then that. Though, I think this kind of thing should be done outside. Somewhere here. So we just do the clean, and then we render the rest of the stuff, right? So we render the rest of the stuff. So we prepare everything, clear render line. Okay, so what we're gonna do in here, we're gonna try to do this thing, right? So between clear and sync and draw, we're iterating through each individual row of the editor, and we try to render it. So in that case, we're going to do free glyph render line sized FGB. So here's line characters. That this is the tile, right? This is the tile, but we need an actual position, if I understand correctly. All right, an actual position, and the actual position is going to be vector 2f. So in terms of x, I suppose it's going to be just x. In terms of row, it's going to be minus, right? So it might be also float, right? But also multiplied by the amount of pixels. So we set it to 64. Let's actually keep it like this, 64. Right, and that will sort of advance this entire thing down there. All right, so is it gonna work? Implicit declaration of function. Okay, so that didn't fucking work. So what was wrong in here? Free glyph. So I think it's called differently. Oh, it's called line. Free glyph. I call it for some reason slightly differently, inconsistently, I would even say. Alright, so we're about to do something very, very cool. 4 hours, mother flipper. Get cooler. Okay, it took me 4 hours to integrate the FreeType into the editor. So it's gonna be that src main.c. There we go. So we don't have a cursor yet, but we're gonna add it soon. So it's pretty cool. So we could make maybe the distance between the lines a little bit better overall, but we do have support for FreeType fonts, by the way. And we can actually use whatever FreeType fonts you want. So we can, for example, use Comic Sans. So let me see. I'm telling you, like, my streams usually pay off at the end, so stay tuned. So yeah, that's the problem of streaming this kind of content. It's just like it's a little bit boring while you're doing it, but at the end, like, I'm doing something cool. I'm trying to make something cool and interesting. All right, so if I take a look at the this thing, it's a FreeType OpenGL. We have a bunch of things in here. We can try to use the Comic Sans one. Right, so it's gonna be something like that. So comic. So C, TTF, right. So let's try to recompile this thing. Thank you for appreciating it. This is a Comic Sans now. Yeah, we have a Comic Sans. So you can use Comic Sans now if you want to. Yeah, and it's not monospaced one. So this is not monospaced font. I'm not sure if Jay is still watching, but because she asked the question about like whether it supports monospace or not. Oh no, she didn't ask the question. I think she was just explaining to somebody. Yeah. So this is how it looks like. Hi. So this is not monospaced one, and not monospaceness actually works fine. Yeah, you can clearly see that they are not monospaced in here, so it's just works. So that's pretty cool. It would be nice to have a cursor, if you know what I'm talking about. It would be nice to have a cursor. So let me maybe try to implement. How will we implement the cursor? I'm not even fucking sure. The easiest thing to implement the cursor would be to just use the background color. Vim integration, we don't really need to integrate. We can like straight up implement the key bindings for Vim or something. Come on. Let me grab the frag shader, and it's gonna be a tile frag, and yeah, I might as well just steal this code. Free glyph dot vertex. Ow. So NTC. Oh, okay, I see. TC, I see. Yes. How is gonna work? Yeah, it should work. Alright. So now we should be able to have like a foreground color and shit. Think. And we can use that shite for the cursor. But in case of a cursor, it's gonna be kind of interesting, I think. The cursor needs to be, like, because of its not monospaceness, the cursor needs to be rendered like within this process. Right. So we need to inject the editor in there somehow. I don't know. Saving one more time, Terry. Didn't you just... You misunderstand what I'm trying to solve in here. Congratulations. So, editor, cursor, row. Okay. So if it's equal to the current row, right? If it's equal to the current row, we might as well actually put something like this in here. So column, otherwise it's gonna be null. Yeah, so basically if we are on the same row and we're on the same row, we're gonna pass a pointer to the column. We're passing the pointer to the column. If not, we're not passing anything there. And we're gonna extend this entire thing. So tile glyph, it's kind of a hack, but I think it might work actually. Size t column. Glyph.c. Sized. So this is going to be the column. Right, and essentially in here, if column is available, yeah. If column is available and column is equal to I, we're gonna set the glyph background color to essentially white. Right, so it's gonna be like this. Otherwise, we're gonna set the background color to something else. So it's quite important, like the function itself needs to know this kind of thing, so that's why we're passing it there. And oh boy, okay, so here, wait, what? No, it's a, wait. Am I Pepega? Okay, I think I am Pepega. So in the... I modified the wrong header. Okay, I'm right. I'm getting a little bit tired. So I'm getting a little bit tired. Just cut me some slack, right? I'm almost, yeah, so I should have not done it in here. Ooh, alright, so what's, oh my, why is it so annoying? Just work. Just work. GitHub Copilot. And I'm modifying the wrong shit. Oh my god. The fuck? Okay. Yeah, I guess that's the content. Right. Watching mentally ill person suffering. Right. Okay, so what do we have in here? So this one has to be null. Okay. Yeah, kind of like that. Doesn't really work that well. So I think the cursor has to be something more like a line, but that will require actually implementing like a separate shader, I suppose. I think we need a separate shader to actually implement that. So where is that? Where is that? What am I going to do? Okay, so TTF, yep, so here's going to be Victor Monev. Okay, so this is gonna be the thing. I hate this cursor. I think it looks super ugly. So I'm not gonna actually include that. I don't like this cursor. So we're gonna straight up just strip it off. So it's gonna be something like this. Okay, so for a while we're not gonna have any cursor for this renderer, I suppose. Right, so we're gonna implement it a little bit later. So I suppose we also want to be able to switch between different renderers, maybe. Oh yeah. Also, this probably won't work on Windows. Right. I'm actually typing absolutely blindly. 1, 2, 3, 4. Printf. Hello world. Okay, so that's pretty cool. Really like that. What if I make the font even bigger? So we have 64 like this, and we could maybe do something like define free glyph font size. It's gonna be 64 free glyph font size, and another 64 free glyph. So now we have a centralized place in which we can update the size, and I want to make it slightly bigger. Alright, so 128. I'm already going fucking crazy now. That's cool. Hello, chat. Vector mode actually looks very cool. Oh shit, by the way, the camera is broken. The camera is broken. Alright, so we have two things to fix in here. Alright, so it's gonna be free glyph renderer does not support cursor. Camera location is broken in free glyph renderer. So, and we're gonna set it to 64 for now, and we're gonna fix everything hopefully later. So for the cursor, we definitely need a separate program, I think. I think we need a separate program. I mean, shader program and stuff like that. Just to be able to render a single line. I wonder how we're going to do that. That's very interesting. I suppose as we render the pen, right, so if we detect something, we like the cursor, the location of the cursor, we have to issue a separate draw call probably. But yeah, in any case, I think the time has come to do the committee and quite possibly pushy. So let me commit that, let me remove this thing, also that stuff, and what do we have in here? So I suppose we finished the implementation. So introduce flavor renderer, implement, and integrate free glyph renderer, and let's push that right into the repo. So it's probably not going to build first try, because you also need to fix the Windows build and stuff like that. Maybe I'm going to pull out the old Vodus build, because I think we built Vodus on Windows with FreeType or something. We'll see how it goes. Right, but here is the result of today's stream. Here is the result of 4 hours work on integrating FreeType to our text editor. Right. And I think it's hella cool. I really like that. 1, 2, 3, 4. So now I understand how this kind of shit works with OpenGL. Now I know how to render like a proper text with OpenGL, which is going to be very useful for me if I'm going to start like doing serious game development, right? Because I kind of got tired of that pixelated bitmap font. I think it was extremely boring, but now I can just use whatever font. Chat, by the way, tell me your favorite font. Which font should I check? Like, we can try to use any TTF font in here. It should work. Oh, we also have like a mouse support. All right, so let's take a look. What is that? So where can I do? Oh, why? Oh my god, this is a horrible way. Like, oh, you're fucking serious? Download. Wonder what's. Is this because I'm running this thing? Probably. Is my internet slow? Maybe my internet is slow. Okay. This looks fine. This is annoying. Single download button, holy shit, it's impossible task in 2020. Why is it so fucking hard to do that for your Zevka? I don't even know how to pronounce it. Like, holy shit, just give me a fucking download button or something. Excuse me? Oh yeah, I have to do copy, download, JetBrains, and just copy it in here. Don't force me to go through some bullshit, okay? It's just, it's not pleasant. Alright. Okay, so we have that. Alright, so we have TTF. Right, so, and does it have a regular? Okay, so we can use mono. Right. TTF. We probably have to do it like that. And it's located in fonts TTF. Okay, fonts TTF. All right. Good try. Is that it? I think that is it. I think it looks like a different font. Cool, right? But I don't like any of these new programmer fonts like Fire, Hack, or Zevka or whatever. To be fair, me too. It's just like I'm okay with Ubuntu mono, and it's just fine. First try. Deja Sans mono is also okay. To be fair, I've been using Deja Sans mono for a very long time. When I only started to use Linux or something. Alright, so the lesson for you, Zevka, just make a website with a big download button, and that's it. And it's not even that hard to do with GitHub pages. Just, I don't know, set up some GitHub pages and just big download button, so people don't waste their time. All right, so I guess, yeah. Let me see. I'm gonna put it like this. Victor Monov regular. I wish Victor Monov worked with Emacs. Unfortunately, it doesn't work with Emacs. And that's why I'm making my own text edit, so I can use Victor Monov. Oh, that's precisely the reason. That's literally the reason. Yes, I have an agenda. I have a goal, and that's why I'm doing everything. Right. What says it? 1, 2, 3, 4. Hello, world. Okay. All right. I guess that's it for today. I hope today's stream was interesting for somebody. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all next time. I don't know when, I don't know where. We'll see about that. Yeah, check out the description, check out all of the links and stuff like that. And I gotta go. Thanks everyone for watching. Love you.